Hi, welcome to Coding Bootcamp's YouTube channel. Subscribe now and join our live stream session later. See you.
Hello, and welcome to Coding Bootcamp's Introduction to the Python Programming Language. I am your instructor, Stephen Elmeroth, founder of PrimeSite. I've worked for some big and small companies and done mostly Python recently, writing bots for Amazon and Facebook. And also now I'm getting back into JavaScript, which has come a long way, so stay tuned for those courses. This introduction to Python has no prerequisites. It's an introduction. And we're going to talk about Python 3. Python 2 is still sticking around, but this course is about Python 3. And we're going to talk about the command line, some GUI concepts, language fundamentals, data and execution models, talk a bit about flow control constructs, the branching and looping. Basically, a branch is an if statement. If this, then this. And you can loop through items in a list, for example. So conditionals, list expressions, all other kinds of expressions, all kinds of expressions actually. We'll talk about exception handling. When something goes wrong, you want to handle the errors. Talk about the string object and about organizing our code into functions and classes, which gets into object-oriented programming. Talk about arrays, which Python calls lists, different collections, and their dictionaries, the so-called dict. We're also going to talk about, since we're talking about functions, we're going to talk about arguments and parameters. At the end of the course, we're going to go through some projects. You're going to want to see these. These are actual code we're going to go through line by line. I'll explain what each line's doing and show you how it functions. I'm going to pull up the debugger and we're going to see what each line does line by line and see what all of the internals are. So we're going to fill a variable and we're going to look at them. See what the contents are. See what it looks like. See what Python sees. So what's the takeaway? You're going to be able to hopefully program a Python script by the end of this course and maybe get one step closer to getting a job in Python, perhaps. So the next course after this one, you might want to get into object-oriented programming. Like I said, classes, create instances from classes. Python's an object-oriented language. That would be your next class after this. All right, so if you want to know more about coding bootcamps, check out codingbootcamps.com and sign up for the course. We'll see you there. Hello, and welcome to Coding Bootcamp's Introduction to the Python Programming Language. I'm your instructor, Stephen Elmeroth, the founder of PrimeSite, a small tech company. We deliver web systems. I've worked for large and small startups, and doing mostly Java, PHP, Python, and JavaScript. And recently for Scraping Hub, writing spiders for the big name brands. This is an introductory course, so there's no prerequisites. But before we get started, let's just view the outline. So this will be a 10-part series. This is part 1, Introduction to Python 3. Okay. This video is for those with a basic understanding of programming. And to get the full advantage of the course, it's good to have some prior scripting knowledge. So let's get into the objectives of this course. We're going to talk about the origin and goals of Python, the overview of its features, how to get and install it, how to access the documentation, talk about PEPs, talk about Python's strengths, and we'll talk about how to use Python with other programming languages. All right, so Python originated around 1989, created by Guido van Rossum, the benevolent dictator for life, as he is known, or was known at least. And at the time, he was working for the National Research Institute for Math and Computer Science in the Netherlands. And he released version 1 November 1994. And nobody really talks about Python 1. The only Python people really talk about, well, up until recently, Python 3 is being used, but really Python 2, everybody used Python 2 after 2000, and currently Python 2 is at 2.7, and Python 3 is already at 3.8, the 8th version of Python. And people still download and install Python 2. So there was a big jump between Python 2 and Python 3. People said Guido did Python 3 wrong. He introduced it wrong. Or the reason that I liked Python 3 over Python 2 was that he didn't do what PHP did, which was carry over all the legacy code and make it backward compatible to previous versions of PHP. There was some problems with Python 2, and instead of carrying that baggage around, Guido said, let's just get rid of it and, start with a fresher version. So he sort of got rid of some of the backwards compatibility, which is what major version releases are. They're not backward compatible. So there was a slow adoption for Python 3. And the biggest, I guess, of the reasons that they fixed in Python 3 was Unicode support. Python 3 has full Unicode support. And the other change that people know about was the print statement was changed to a print function. So you needed to use parentheses with your Python. We'll cover that in the video. So Guido's goals with Python were to make it easy and intuitive, and just as powerful as the major competitors of the time, like C, or Perl, perhaps. It's open source, so anyone can contribute to its development, in theory. The code is understandable as plain English. As we'll see, it reads very nice, very beautiful, with its indentation. And it's also suitable for everyday tasks, allowing for short development times. So let's talk about Python's features in the next couple slides. All right, it's simple. It's a simple and minimalistic language. So reading a good Python program feels almost like reading English. The pseudocode nature of Python is one of its greatest strengths. It allows you to concentrate on the solution of the problem rather than the syntax. So, as Guido says, Python is read far more often than it is written. It's also easy to learn. Python has few keywords, simple structure, and a clearly defined syntax. It's free and open source. In simple terms, you could freely distribute copies of the software, read the software source code, and make changes to it. Depending on the license, of course. It has a high-level language. It's not a low-level language. It's a high-level language. So when you write programs in Python, you never need to bother about low-level details such as managing memory used by your program, like C++. It's portable. Python can run on a wide variety of hardware platforms. It has the same interface on all platforms. Interpreted. It's not compiled, it's interpreted. No separate compilation and execution steps. The program is run from the source code. So that can make things a little bit slower, but more portable. You don't need, and by more portable I mean you don't need a virtual machine. You can just run it anywhere you have an interpreter. Object-oriented. In object-oriented language, the program is built around objects which combine data and functionality. Python has a very powerful but simple way of doing object-oriented programming, especially when you compare it to languages like C++ or Java. It's also scalable. Python provides a better structure and support for large programs than shell scripting, for example, or Perl for that matter. Extensive libraries. The standard library is huge, some say to its fault. It can help you do various things involved in regular expressions, documentation. Many things are packaged in the standard library. But also there are many third-party libraries written. Many third-party libraries. It's interactive mode. Python has support for interactive mode, which allows interactive testing and debugging of snippets. We're going to look at that in the terminal. Getting and installing Python. All right, let's find out how to get and install it. So you open a terminal, and you go to Downloads, install the latest version by clicking on the download button, and then you save the MSI package and run the installer. Select the defaults and select yes to disable the path limit. We're done. That is for Windows. Now let's take a look at what it might look like if we were running, for example, Linux. So let's go to Downloads, click the big yellow button to download the latest version, and it is going to download an XZ compressed file, just like zipped file. You don't have to be able to read that, it's just giving you an idea of the basic functionality. So let's have a look at what that might have downloaded for us. So let's go to Downloads. And we can extract it to its folder. Let's go into the folder. And we can look at the README file. If I could type, of course. So what do we do? How do we use this? What do? We downloaded a bunch of source files, and now we are going to have to compile them. So first we get to the command line, run configure, then make, and make test. So we could try that if we wanted to, I suppose. It's right. We have a configure file, and it's going to check for if we have our compiler installed, and make sure we have the ability to make it. This will also generate a make file for us, but it takes a long time to compile depending on your processor, how fast it is. It's going to take a little while, so it's not quite as... Okay, see, we can run make test. First we have to run make, I suppose. We want to build it, so it's going to compile all the modules. But we'll let that run in the background. Now, back to the show. Accessing Python documentation. All right, pretty simple. You go to python.org/doc. Yeah, let's look at that.
Thanks for watching. Feel free to add your questions as comments down below.
Python docs. Let's click on the big yellow button just like we did for download. See what we get. What's new? Tutorial, library reference. And the main thing we want to look at is probably the API. So maybe that's under language reference. The import system. Right. The ecosystem is huge. There's a lot to see there. Alright, so what are PEPs? Python Enhancement Proposals. A PEP is a design document providing information to the Python community. So you create a PEP. If you have a new idea for Python, you create an enhancement proposal. You want to enhance Python, so you create a proposal. For example, moving from Python 2 to Python 3, we went, somebody found a problem with the print statement being a statement. And now you can see print statement now needs parentheses. Before it didn't have parentheses, but now it's a function, so it needs parentheses. So somebody had to write the PEP for that. Let's see if we can search for that. Python PEP print. Oh, our make is finished. Now we can make test. In order to test to make sure they're compiled okay. So here we have PEP 3105. Make print a function. So this was done by George Brandl in 2006. So he gave all of this. The title says it all. This PEP proposes a new print built-in that replaces the print statement and suggests a specific signature. Okay. So you can read about all the other PEPs here. PEP index, PEP 0, and I guess one of the big ones is, let's see, is it 8? Somehow, PEP 8? PEP 8? PEP 8 is the one PEP maybe everybody should know. What? PEP 8 can't find PEP 8. I think it's 000008. Right? So it's probably 00008. It was 2001. One of the first things Guido did. Guido wrote it. So he talks about style guide, standards. You can see it's a pretty long document talking about what to do, what to not. So this is the wrong way to do indenting, operator indenting, and this is the right way to do it according to PEP 8. All right, let's get back into it. Python's strengths: its readability and simplicity. Like Guido said, it's read more often than it's written, so it's easy to understand code written in Python. Development time: Python programs can be developed 3 to 5 times faster than Java programs. Libraries: easy to use libraries in Python. Just install and import. User community: has a huge and supportive user community all over Google as well. So just search and find the answer. And our compile failed. Make failure Compression requires missing. Okay, so I need to install zlib module. So, see, it's not so easy on Linux. Although, if the download would have had precompiled versions, which they apparently don't. Huh. I have to check that, but installing things on Linux is not always necessarily that difficult. Okay, back to it. The user community is big. Now, using Python with other languages. Let's wrap up with this. Python can be used with other languages. The Python C API, which is a C library that helps to embed Python modules into C programs. It's built and distributed with Python. Now, IronPython is an open source implementation of the Python programming language, which is tightly integrated with the .NET framework. And Jython is also an implementation that lets you run it in JVM. So, for example, Jython is written in Java, and it specs out the maybe 100% Python API. So you can use Python code and run it in JVM. And why would you want to do that? Maybe because you have other code written in Java that you want to access. This would make it easier. Maybe you want to access Swing or create some user interface with Java's screen programming libraries. All right. An assignment. Install the latest version of Python 3 and an IDE, an integrated development environment. All right, so wrapping up the live coaching sessions for Python available at the following URLs. You can see those on the webpage. There will be a follow-up class to this, object-oriented programming examples for Python. You'll also be able to see some other training for this platform. The next session, we're going to talk about using Python. So this was an introduction, and we will then, on the next session, see you for using Python. Okay, thank you very much. Hello, and welcome back to Coding Bootcamp's Introduction to the Python Programming Language. The last video, we covered an introduction to Python. And now in this video, we're going to be using Python. All right, so let's get started. First, the objectives of this course. This session will cover executing Python programs from the command line and talk about some of the command line options as well. Talk about environment variables and a bit about creating Python GUI applications, graphical user interfaces. And at the end, we will briefly discuss the Python standard library. So let's pull up a command line. Now, if you don't know what a command line is, it's referred to as a shell also, or a terminal, which is a shell program running inside of a terminal or terminal emulator. And you probably should get used to using one. You don't need one for this course, just go ahead and watch me do it, but it's a good idea to try to do as much as you can from the command line, because we'll be using editors and other integrated development environments and even coding online on web pages. But it's good to get familiar with the command line. So pull one up. That's what we'll do. That's what I'll do here. Pull one up and see you have a prompt there. Let's make it a little bigger. Okay, so let's type in Python and see what happens. Let's say -v to show the version. Hey, look, we have Python installed. Wow. So where are we running it from? User bin Python. Okay. User. So user bin Python is symlinked to Python 3, which we can see by running our version. So this is an command line option. -v, we gave it the -v switch, so it'll print off the version. So we can add a path variable to our shell environment. If we don't have Python in the path, then we can add a path environment variable to point it to where our installed version is. But if we look at my path variable, remember let's see here. Got to keep my screens up to date with what I'm doing here so you guys can see what I'm doing. All right, so you can see we listed I said type Python and it told me it was hash to user bin Python. So now if I do echo path, now I'm in the shell, remember. This is not Python yet. This is just shell scripting. Just shell commands, which also you could think of as operating system commands. So my actual Python installation is user bin Python. And I'll print out my path here. And you'll see we separate here by colons. Then I have the first place it will look for is in yarn. Applications install their own paths into the path variable. So somewhere in here should be user bin, user local bin, user bin. So it's in my path, so it's working. All right. So now let's create a file and see, we have an example file, so we can remove it. Now I'll create a new one. We give it a py extension. Okay. And that's the standard extension for Python programs, .py. So we can run this program. See, there it is. Now if we list it out, there's nothing in there. So now if we try to run it, then nothing happens. So let's try to edit that file, example.py. All right, shall we? So let's look inside our editor.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
And we'll type in print hello world. Now we save it. And we come back, and now we can run it from here. I'm using Visual Studio Code. And if you can run files directly from the IDE. This would be an integrated development environment in Visual Code. So there's a little button for running it. So I execute it. It actually opens up a shell. It executes it. You can see it gives the full path to the Python executable. And runs the absolute path to the file. And you can see it executed and said hello world. That's the output. Okay, so here's our shell prompt. Here is our Python command. Here is the file we're giving it to run. And here is the output. Pretty simple program. It's pretty much everybody writes this program the first time to test it out, right? Hello world. Okay, so moving on. There are a bunch of Python command line options. We already saw the -V, but let's try a few more. We can give it a -D to show debugging output as we're coding, or actually as we're in the environment. So you'll see here in a second, we're going to open up Python interactive environment. And when we do that, it can help in debugging. We can also create a bytecode file, PYO file. It's a compiled file because remember Python is interpreted. But you can also generate the bytecodes and run those files, which would save the interpreter the time for compiling it. Make it a little faster. So you can print off the verbose output. That's pretty verbose. So you can see there's all kinds of... It does all this stuff. The first thing it does is it's telling you what it's doing. Importing frozen import lib, then it's importing imp to do the importing. The first thing, then after it gets ready to import, the first thing it really imports is sys. Some warnings and more importing stuff to really get ready for importing. So it does all of this other stuff here, and then finally you will get a REPL prompt. This is also a command line prompt, but now we're inside of Python. So now we can execute commands. Print hello world, just like in the last example. Just like in our program. Okay, so we can exit by typing exit, I think. Is that a function? And since we had verbose on when we entered in, it also told us what it destroyed and cleaned up and before it actually exited. So now we're back to the command prompt. Moving on to the Python command line options, we can import a module with -m. So we can say perhaps Python minus m given a module, we could say HTTP. That's server. So now we're actually running a web server here at this address. So here we are. Now we get a directory listing. We're now running localhost port 8000. I don't know if you can see that, but that's what it says. And here's our example file that we created, print hello world. I know it's probably kind of small, but I'm just giving you an idea here what's going on. So that's the -m switch. You can, now this is the first switch we tried, Python. Row switch. We can print quiet. So now if we can Control C to escape that web server. Now if we just type in Python, remember before we typed in Python -V, and it just told us the version. Now if we just type in Python, we'll go right into the prompt without the, we also typed in small v, and it gave us all of the verbose instructions it went through and imports it made while it was creating our environment. And we exited out and it cleaned up. Now the same thing will happen when we do it here, it just won't tell us. So now it's done all that same stuff and we exit out. It's also cleaning up, but it's not so verbose. And you didn't see most of that because I didn't have the terminal on for you. That's disagreeable. So remember we tried the version, it printed that. We had small v, which entered our environment, our interpreter. This is called the interactive interpreter. So now we have verbose import and verbose cleaning up. But if we just type in Python, it does all that, but it's not so verbose. So, and also the -q switch does quiet, doesn't print our header to tell us, the version and help. So Control D to exit, or we can type in run the exit function. Okay, so we can also list all of the command line options with -h. And now onto the environment variables. There's 4 of them we're going to discuss. Python home is used to set a alternate home search path, a alternate module search path, where to look for libraries. The Python path is, if we look at my environment, we can see if there's any Python environment variables. Python startup is set to nothing. So let's create a Python path environment variable, and it will tell Python interpreter where to locate the module files imported into a program. So if we say Python path equals, let's say, temp, then we could put some modules inside of temp. and we could import them from there. Now, if we want to create a Python startup, then we can point to a file that contains the Python startup environment variable will hold the path of an initialization file containing Python source code and executes every time you start the interpreter. So we could set it to our export. That example. Right? Now we see it set here. Let's get it. All right. It's set to our example file. So, and remember our example file is just says print hello world. But now since we have this Python startup, when we execute Python, it will execute this file for us. So this is our, you can see hello world. It executed that as we started the interactive interpreter. So that's our Python startup environment variable. All right, so creating GUI applications with Python. There's a few ways to do it. Here's 4 of them. You can use the TK toolkit, TK interactive. It's a Python interface for the TK GUI toolkit, and it comes with Python. WX Python is also an open source interface for WX widgets, and PyQt is also a popular cross-platform Qt GUI library. Python FLTK, Fastlight Toolkit, has cross-platform windowing system. Okay, standalone versus web-based applications. Standalone applications are traditional software that's installed on each client system. An example of a standalone application would be Microsoft Word. And if you want to use Word, you need it on every computer you're going to be using it on. So if you have 100 people in your office and each person runs Word, then you got to give Bill Gates $199 for each person. But if you have a web-based application, then each person just goes to the website and uses it either online as a SaaS, software as a service, or maybe they just download it. This would be an example of a thin client like Google Docs, where all you need is a browser. The Python Standard Library is a library available on any machine where you have an application using the specific language. Here the specific language is Python, and the standard library ships with Python. And it's going to have a bunch of functions that we can use in our code. So the standard Python library has 2 things: the built-in functions like len, min, max, and also the imported modules in the standard library like math. So important built-in functions, there's built-in operators, and, or, not. Comparison operators, greater than, equal, less than. Length, using the len function on any iterable objects. Like lists are iterable, strings are iterable, dictionaries. Range holds all numbers from 0 to x. List creates a list. Min and max give the least and the greatest values.
Thanks for watching. Please like and share this video.
Minimum and the maximum. Round, absolute value, power, sorted. Type gives the type of an object. So we can perhaps have a look at, remember, so you get into Python, you type in Python, and now we're in the interactive interpreter. So we can say 1 and 2. That's 2. We can say 1 less than 2. True. We can say, what is the length of the string 1? It's 1. And what is the length of the array? 1, 2, 1, 2, 3. It's 3. How about 1, 2, 3, 4? It's 4. What's the length of 1, 2, 3, 4? 99. Or 88, let's say. 5. Alright, so what is the min? Min is 1. And I dare you to guess what's the max. Gave you an extra second to think about it. 88. So you can round 1.4 to 1. You can round 1.5 to 2. You can give the absolute value for 1.5. Is the absolute value of negative 1.5 is also 1.5. So what is the type of 1.5? Well, what's the type of 1.4? It is a type of class, the float. So that's interesting. Now you notice when we ran these functions, we didn't import anything because they are built in. They're already imported for us, right? So we did Python -v. Somewhere along here we're going to be importing our built-ins where we get all of our built-in functions. And see, we still are running hello world because we still have that environment variable set. So here we ran, again, I forgot to show you the terminal. Python -v. It imports our built-ins for us, and we're still running. We have our environment variable set still because we did -v. It ran our hello world printed out because it ran our example.py function because we still have our Python path startup, right? So if we did, still running that. So moving on, we import the module from standard library modules are built into Python, but you have to import them. So you import the module using the import keyword, like import math, and then you do math dot whatever to access all the functions on the math module. So depending on your IDE, you'll see different functions available to you that you can use in your documentation. So let's have a look at some of these things in math. Math.py. And we'll also look at the random module, which has random.random, and random.sample. So we can say it's standard practice to put the imports at the top. If you'll check PEP 8. Import math. And now we can say print math dot, we could say math.py. And we could give it some values. See, you can tell it, give it files, you can give it string inserted between the values. Let's try that. So we just print math.py. And let's run it. Let's see what happens. So it said hello world, and it said float object is not callable. So we tried to call math.py, but it said it's a float, and you can't call a float, so we can't use parentheses because it's not a function. All right, let's try to run it again. All right, so here's, it printed our 3.1415. This is an irrational, infinitely long number, which it just uses a few digits here. So we can also try to print out math.e. See what that does. There's E 2.7. We could say math.nan. What does that do? It's nan. Math.square root. Now square root actually is a function. So you need to give it a float, and it returns a float. Let's see what happens if I give it nothing. Error. Type error. Square root takes exactly one argument, but 0 we're given. Alright, so let's say this. What's the square root of -1? Let's see if it says anything. Value error. Math domain error. Didn't like that. Alright, what's the square root of 1? 1. And what's the square root of 43? 6.557. All right, let's try to import let's keep things simple. Let's print off random dot, what should we try? Random dot random. And just print off some random number. So there'll be a random, it doesn't really explain it here, but it should be between 0 and 1. So I get 0.2. Let's try it again. 0.4. 0.6. You get the idea. So let's try to run sample. We'll give it a range of 100 different numbers from 0 to 100. Well, the range will be 0 to 99, and let's choose 5 of them. See what happens. So there's a list of 5 numbers between 0 and 99, inclusive. So let's try to use sysargs, argv, all right, and see if we can't find out what our arguments were to our Python interpreter. We don't really know because we're using an IDE. So let's see. We said import sys, and then we don't get to show the turn on. So we say import sys, and then we're going to print sys dot argv. See what happens. So we just have one argument, which is the name of the file we ran. Well, here's our executable. Here's the argv. Now, if we were to go to our terminal and we were to type in, first we will save this code. So we're printing argv, and now if we said Python minus, let's see, minus d. So we gave it no arguments, apparently. So we wanted to, because we didn't give it a file name, it didn't run our example. But it did tell us that it didn't count this. Oh no, it still ran our file. It ran right there, but it didn't have any argvs. So maybe we can run example. It should run this twice, huh? No, it didn't. It didn't run our Python startup because of the Python, but it did give us our argv. So if we ran, it doesn't give switches as they're not part of that. I didn't know that. I thought they would be part of it. And V as well. Hello world example.py. Yeah, it's okay. It's just the file name, so it's. So what if we typed in example twice? Yeah, it just gives us the file names. So it won't run the program twice. Interesting. So let's try using input. And we'll see if we can capture input from the user. So let's try. Well, we can't put that on the command line. For the shell, we have to put it into our interpreter. So let's set a variable color equals, we get the input, and these are not quotes. These are quotes. What is your favorite color? My favorite color is red. Now if I type in red, now if I type in color, red won't do anything. Now the color is red. I could also say print color. But if we're inside of the interactive interpreter, then we can just, it'll assume that we want to print it out. So again, we set our color to the input. What is your favorite color? And then we can print out the color. Red. We can also open text files, write to them, That's also...
Thanks for watching. Feel free to add your questions as comments down below.
That's exciting. But this video is getting a little bit long. I'll leave that for you as an assignment. And I'm going to just leave it there. So that was using Python. And if you want to join us in the next class, we'll be talking about language fundamentals. All right, that's it. Thank you. Hello, and welcome back to Coding Bootcamp's Introduction to the Python Programming Language. In the last video, we were using Python, and now in this video, we will talk about the language fundamentals. Let's get into it. The objectives for this session are talking about Python's lexical analyzer and using whitespace to structure the programs in Python. Also, we'll talk about identifiers and keywords and Python's execution model, the data model, and we'll wrap up with creating and using some variables. So, the lexical analyzer. A Python program is a series of logical lines. A logical line is constructed from one or more physical lines by following the explicit or more implicit line joining rules. The end of a logical line is represented by a new line token. A physical line is what you see when you write the program, while a logical line is what Python interprets as one statement. So in other words, a logical line can be broken up to one or more physical lines. A comment starts a hash character that is not part of a string literal and ends with the end of the physical line. So you can continue a line onto a second line. So you can have two physical lines that, and we're going to show you this in a second, but just if you end a line with a backslash, then physically you'll have two separate lines, or as many as you want, each one ending with a backslash. But according to Python, it'll be one logical line. So if your comment is the first or second line and the script matches a regular expression, coding equal, then a space. If you don't know regular expressions, it's a good thing to learn. So coding can be followed by either an equal sign or a colon, followed by one or more space, white space characters, like a space or a tab. And then one or more words. So this will be, if you have a line that says coding equals Latin 1, this comment will be processed as an encoding declaration. We'll show you that. Actually, so we want to talk about the line joining rules. An explicit line joining, where two or more physical lines may be joined into logical lines by using the backslash character. When a physical line ends in a backslash that's not part of a string literal or a comment, it's joined with the following line. The preceding line forming a single logical line. The line ending with backslash cannot carry comment. Implicit line joining. Expressions in parentheses, square brackets, or curly braces can be split over more than one physical line without using backslashes. Implicit. So that's usually how we do it. It's not a good idea, at least I don't like using backslashes. To end a line with a backslash, it seems very Windowsy. Implicitly continued lines can carry comments. Using white space to structure programs. That's one of the distinguishing characteristics of Python is that you don't use semicolons or curly braces, although you can use semicolons. But curly braces define blocks in other languages like Java, whereas white space is what's used in Python to structure programs. Python programs get structured through indentation. In other words, code blocks are defined by their indentation. It's a language requirement, not a matter of style. This principle makes it easier to read and understand other people's Python code. All statements within the same distance to the left belong to the same block of code. In other words, the statements within a block line up vertically. The block ends at a line less indented or the end of the file. If a block has to be more deeply nested, it's simply indented further to the right. We're going to see all this. And at first, when I first started using it, I really loved curly braces, but because I could indent it any way I wanted. And I said, "Oh, this sounds like Visual Basic had that same." So it sounded very much like Visual Basic. I didn't like it. I didn't like being forced to indent it the way, I didn't like the indenting, but I grew to love it. Because like Guido says, Python is read far more than it is written. So it does help with readability. Using white space to structure programs. Okay, so here is a line of Python code. So we do an import statement. And then on the next line we get some input from user and assign it to a variable called n. Then we increase n by 1. Increment it actually. And then we start a for loop. And this is all in block 1. This is all in the main block. But as we get into the for loop, we're now going to start a new block. As you can see, there's indentation here. And the first line of this new block is also a for loop, so we're going to indent a further 4 spaces and continue with a third block. And the third block continues down with declaring a c-square variable and a c variable and then an if statement. But the if statement itself starts a new block. So there's a 4th block starting. So the first block, second block, third block, and then a 4th block is starting. Identifiers and keywords. Identifiers are referred to as names. They can be referred to as names. Within the ASCII range 0 to 256, the valid characters for identifiers are the uppercase and lowercase letters A through Z, the underscore, and, well, the underscore, except for the first character, can be 0 through 9. So you can't start a variable with 0. You can't say 0x equals 9. 0x equals ABC. 0x equals a list. You can't have a variable that begins with a number. But you can say x0 equals anything. So, keywords. The following identifiers are used as reserved words or keywords of the language and cannot be used as ordinary identifiers. Python's execution model. A Python program is constructed from code blocks. A block is a piece of Python program text that is executed as a unit. The following are blocks: a module, a function body, a class definition. Each command typed interactively is a block. A script file, a file given as standard input to the interpreter or specified in command line argument to the interpreter, is a code block. A script command minus C option is a code block. The string argument passed to the built-in functions eval and exec are code blocks. Those are all different ways to tell the interpreter what code you want it to interpret. Script file or command line or an eval exec function call. A code block is executed in an execution frame. A frame contains some administrative information, user debugging, and determines where and how execution continues after the code block's execution has completed. Naming objects and object binding. An object can be referred to by multiple names. Binding a name to an object doesn't change it. Changing some property of the object, however, will be reflected in all other names bound to that object. For example, consider the below list object with two different names, A and B. Both these names will point to the same list object. If we change the value of a list object variable A, it will be reflected in B as well. So we can set A equals B equals the list 145. So then if we take the list A, index 0, which is the first element, sequences are 0 indexed in Python, as most other programming languages. 0 index means they start at 0, so this is index 0, index 1, index 2. So A sub 0, as we say, we set that to the value 3. So we read this as A sub 0 equals 3. And then now we print A, and now you can see it's 345. It was 145. Now it's 345. Now if we print B, it's also changed. Even though we didn't change B, we only changed A. But since these two things both are just names, think labels, not boxes. So the label A points to this object, and label B also points to this object. So when the object was changed, either label we use to get to the object, we see that the value is changed. Python objects, values, and types. Everything in Python is an object, including variables and functions. Every object has an ID, a type, and a value. Let's create a simple object and see the value type in the class. So we create a variable x, which equal to 5. Then we display the value of the object. Once we're inside of the interpreter, we can just type the value and it prints out for us. And we can see that if we type it, use the ID function to print off our x, we see the value is 5 and the ID is this big number, integer number. And if we print off the type, then we'll see it's of the class int. Mutable and immutable objects. Objects in Python are mutable or immutable. Mutable objects can change values, immutable objects cannot. Some immutable objects look like they are changing values. Some immutable objects look like they're changing values, but that does not happen. Let's see in the below example. Note that the integer value is an immutable object. So we created a variable pointing to an integer object with a value of 5. And we display it, and we call that object with the ID function, and we get the ID. Now, let's note that ID.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
And now, here we don't change the value of an integer object, we just point it to a different integer object. So now we set, before we had x equals 5, and now we have x equals 6. So those are two different objects. One object is 5, one object is 6. And now when we print off x, its value is 6, and it has a different ID. So it's a different object. So x doesn't change, x just points to two different objects. Creating and using variables. A variable is a way of referring to, and before we get too far down the list, let me talk about mutable and immutable objects for a second. Let's look at this article from the Invent with Python blog from 2018. Now, this is a pretty good article here, posted by Al Zweigart. So, are tuples mutable or immutable? Now, most people say that tuples are immutable. So, mutable means changeable. Immutable means unchangeable. So, in Python, tuples are immutable. And immutable means the value cannot change. These are well-known basic facts of Python. While tuples are more than just immutable lists, as chapter 2 of Luciano's book Fluent Python explains, there's a bit more ambiguity here. So the title of this article is Python tuples are immutable, except when they're mutable. So if you want to check this article out, it's under, you can go to inventwithpython.com. And I'll just briefly skim over it, but he's talking about the same thing as we're talking about now with the ID, getting the ID of a variable, and you get two different variables and they point to two different objects. Same thing with A and B, spam and eggs both point to this object. Make it a little bigger here so we can read it, huh? But the thing is, tuples can hold hashability. We're going to cover this later. Hashability, according to the glossary and the official Python documentation, an object is hashable if it has a hash value which never changes during its lifetime. So sometimes when you try to use different objects in Python, you'll get an error that says it's not hashable. We're going to cover that later. But hashability and immutability are similar, but they're not the same thing. Immutable objects can be hashable. Mutable objects can't be hashable. It's not possible to hash a list, but you can hash a tuple, unless you can't. So that's what we're talking about here, is the mutability of tuples. Error, unhashable type, dict. So it seems that if a tuple contains a mutable object, it can't be hashed. Raymond Hettinger, if you don't know who Raymond is, you want to keep an eye on him. He's a very listenable Python expert. He explains with lots of context why immutable tuples can contain mutable values. See, there's a tuple here that contains a list. So here is a tuple with all three entries are mutable, immutable values. A string is an immutable object. So you can use this mutable object as a key for a dictionary. We'll talk about that later. But here, if we try to use a tuple with a mutable list inside of it, we get an error because this could be changed. And we're going to talk about that too. We'll see how we can do that. All right, so are tuples mutable or immutable? We go down to the epilogue. The question is, said Humpty Dumpty, which is to be master? The words are the human. So basically, this guy says he thinks I'm going to continue to say that tuples are immutable, even though it's possible to create mutable tuples. Let's see if we can do that. Is that possible? Let's enter Python, our interpreter here. Now if we say x equals 1, 2, 3, now can we hash x? Ah, there's our hash for x. Now if we say x equals 1, 2, 3. Now 3 is a list. Now let's try to hash it. Oh, we can't hash it. Unhashable type list. List can't be hashed. So, okay, let's go one step further. Let's look at x sub 2. That's a value 3, right? So we can say x sub 1 is 2 and x sub 0 is 1. So x sub 3, x sub 2 is the list 3. So we can say x sub 2 sub 0. What do you think that's going to be? So we took the index of x, index 2 of the tuple x, gave us a list, and we took the index 0 of that list, and we got 3. So now let's change it. All right, so let's look at x. That's x. So we get that 3 again. And now let's set this to a value of, oh, no error. So apparently, right, type x tuple. But apparently tuples are mutable. Interesting. So it's a nice title. Tuples are immutable. Until they're not. All right, let's get back to it. Now, a variable is a way of referring to a memory location used by a computer program. This memory location contains values like numbers, text, or more complicated types. We can use this variable to tell the computer to save some data in this location or to retrieve some data from this location. While the program is running, variables are accessed and sometimes changed, i.e. a new variable will be assigned to a variable. A new value will be assigned to a variable. You can, like we just did. Assigning values to the variables can be realized with assignments, with the equal assignment operator. There is no declaration of variables required in Python. If there's need for a variable, you just think of a name and start using it. So you don't have to define anything. You just say x equals 1. You don't have to define x anywhere. That's it. That's the definition of x in the assignment. Value and type of a variable can be changed during program execution. So the variable actually doesn't have type. The variable points to objects that have type. So it's not that the variable changes type, the value of the variable changes. In other words, the object that the variable points to changes. Points to a different object with a different type, perhaps. All right, let's So here we don't have to declare x anywhere. We just say x, we use the equal operator. We say x equals 27. So we're defining x, and implicitly it is an integer with the value 27. Now we say x equals 28. So the value of the variable changed because the value is the memory address. So now the variable points to a different object, 28. Here's an object in memory somewhere, 27. X was pointing to it. We create a new object in memory with the value 28, and now x points to that one. And now we take that same object and we create a third object. It's a float, 0.5. We add them two together, create a new object, a fourth object for that, and now x points to that. Now we create a fifth object, a string, and now x points to that. Python has many different built-in types, and it is possible to define your own. The principal built-in types are numerics, sequences, mappings, classes, instances, and exceptions. But let's focus on the following types: the numerics, strings, lists, tuples, and dictionaries, also known as dicts. Numbers are immutable data types which store numeric values. Number objects are created when you assign value to them. So x equals 1, it creates a numeric object. Del x, it deletes it. Pretty simple. So you can do, and then the next time garbage collection runs, you will free up that memory space. Python supports different numeric types: integers, floats, and complex numbers. So integer like 1, a float like 1.5, and a complex number like pi, for example, or some fractions. Python converts numbers internally in an expression containing mixed types to a common type for evaluation. Sometimes you need to convert a number explicitly from one type to another to satisfy the requirements of an operator or a function parameter. So int of x, you can convert whatever x is. Let's say x is 1. Now we convert x to an integer. Well, it already was an integer, so it's still an integer. We can convert it to a float, so it'll be 1.0. Complex, it'd be 1. And complex of 1 and y, let's say y is the imaginary part. And you need to get into complex numbers to find out what's going on there. Strings are the most popular immutable data type in Python. String data types can be created by enclosing characters within quotes. For example, x equals hello world. Substrings of strings can be accessed using the square brackets for indexing, like x sub 1 would give us, what do you think x sub 1 is going to give us? It's not the first character, right? It's at index 1. And since strings, like other sequences in Python and most every language, are 0 indexed, 1 would be the second character. As we can see here, it's E. So now we print, starting at 1, we print the first 5 character up until but not including the 5th character, or index 5, I should say. So that would be, yeah, the 5th character. And we could print starting at nothing, which is the beginning, and we print 3 characters. This is actually index 3. A multi-line string can be created using escape character for printing. So if we have the string first line, second line separated by a \n, which is a new line character, then when we print it out, we're going to get the new line character here at the end. Now if we want to actually print the \, we can either double \, it, or we can make the string a raw string by using an R. It looks a little weird because the R is actually right at the beginning of the string, outside the quote.
Thanks for watching. Please like and share this video.
But then when we print it, it just prints off the backslash as a normal backslash. And if you don't know about backslashes, they're much like the space. It's a special character. You gotta watch out for spaces and backslashes. Backslash usually begins an escape sequence. In this case, escape sequence is the non-printable well, you can't see it. It's a new line. Or a line, as they say in teletype, line feed. But if you use a raw string, then it will actually just look at the backslash as a normal character to print out. So no new line is printed. Python lists. All right. Lists can be updated, providing the index values on the left side of the operator. So if we have, for example, let's say fruits equals apple, mango, and then we want to say fruit sub 2. What fruit do you think it's going to be? We don't have any fruits. We don't have any fruits at index 2. So we could set it to something, maybe banana. List assignment index out of range. We can't just create a new entry in a list by accessing it like JavaScript. So we have to do fruits.append banana. Now when we say fruit sub 2, we get banana. So if we say fruit sub 0, what's that going to be? What's fruit sub 1 going to be? Mango. Alright, maybe that's a little hard to read. Alright, so we want to append cherry. Now if we want to say fruits sub 1, that's mango. But can we replace it now? Can we now say this is piña? Now what's our fruits look like? It just changed it in 9. So the list is definitely a mutable data type. And we can also delete it with delete fruits. Lists can be updated by providing the index, as we saw. A tuple is an immutable sequence of Python objects. And you know what we think about tuples. They're mutable. They are immutable until they're mutable. Tuples are sequences just like lists. The main difference is tuples cannot change their values. Syntactically, tuples use parentheses, whereas lists use square brackets. So you can see some tuples there. They're just like lists, but they use parentheses instead of square brackets. So this is also a tuple. Right, we can say either with or without we can declare it without the parentheses. We'll assume that we want a tuple. The dictionary. Python dictionaries are key value pairs. Each key is separated from its value by a colon. The items are separated by commas. The whole thing is enclosed in curly braces. An empty dictionary without any items is written with just 2 curly braces. Keys are unique within a dictionary, while values do not have to be unique. The values of a dictionary can be of any type, but the keys must be hashable. Like we talked about before, it's a special immutable type that's not only immutable, but it also has to be hashable, so it's a pure immutable type. Things like strings or numbers or tuples that contain only hashable entries. A Python dictionary can be created like so. The language construct here, we declare a variable, and right away we are using the assignment operator for a curly brace. And there's our key. There's our key value separator. And there's our value. So this collectively is the first entry. Then we have our comma. And there's our second entry. And a comma and a third entry. So this dictionary creates a variable we put in dict. Name Zara, age 7, class first. So to access the value, we can say dict subname, and we'll print Zara. If the key doesn't exist, it will throw an error. Only 1 entry per key is allowed. Duplicate keys are encountered during assignment. The last entry wins. So there's different. You can delete a dictionary. You can clear all the entries out. Now, if we now this I never tried here, but can we assign dict as a variable name? Dict equals dictionary. Now we say dict. We can override the dict keyword. So this is a horribly bad idea in programming. You would never want to have a variable called dict, because it's confusing whether you're pointing to your variable or the actual dict. See, this is how it should be. It's a class, not a variable. Something to keep in mind. Well, let's wrap up with that. And so now in assignment, we write a program which uses the 5 data types we talked about and performs some operations on each one. Okay, guys? Well, that's it. I'm going to leave it here. Next time, let's talk about flow control constructs. All right? So that's it, guys. Thanks a lot. Hello. Welcome back to Coding Bootcamp's Introduction to the Python Programming Language. Last time we talked about language fundamentals, and as a recap, when we discussed Python's lexical analyzer, we skipped over something I'd like to expand on a little bit, and that is the idea of physical lines and logical lines. Okay, so here we also declare the coding for this file to be UTF-8. We talked about that, but there's an example of it. If we had a different character set, see down here we could change our character set to Latin 1. And but most files use UTF-8. So here we're setting 3 variables, and each of these variables is a single logical line. Each of these statements exist on a single logical line, but each of them take up 2 physical lines. So the first is an explicit line joining method with the backslash. Has to be the last line. See, this is not, if it has an extra space here or anything after here, even a comment doesn't count. It's not valid. But if the backslash is the actual last character, then it will join the next line. And this is an implicit line joining with a type of, so we have here parentheses, but you can split up dicts or lists in multiple lines same way. And this is a multi-line string. So let's print those out, see what we get. Yeah, there's X, there's Y, and there's Z, multi-line. So we could print, we could make this instead a tuple. We'd say 1, 2, 3. Yeah, that looks valid. Our ID does not complain. Let's print them out. Right. There's X, there's Y, and there's Z. Okay. So that was language fundamentals, and this time we're going to get into flow control constructs. Alright, so let's get into it. The objectives of this video are to talk about if, elif, and else statements, the if suite, also about creating loops with while and for, understanding iterators, returning values with the return statement, loop modification with break and continue, returning, and talk about a bit about generators and iterators. Okay, first, one of the primary functions, one of the primary uses or implementations of a programming language is a branching mechanism. So to go left or right, true or false, and Python is no exception. So the traditional if-else in Python, in JavaScript, we can say else if or else if. But in Python we have elif. So the syntax in Python is an if statement. It begins with the if keyword, and then we have an expression.
Thanks for watching. Feel free to add your questions as comments down below.
And then we have a colon. So that makes up our if statement. So this if statement begins a block, which are called suites in Python, and consists of code that is indented under the level of whatever's controlling it. So here we have an indentation. So this is a block, and that ends because we're unindented at elif. Same thing with a colon, begins a new block. And finally we have the else branch, then colon, and a third block. So how this works is, remember we have the if statement, the expression, and the colon. So the main thing we're looking for, so it's on the left it's the if, and on the right it's the colon. So we're basically talking about expressions. So we say, if this is true, then we execute this code. Else, if this is true, so if this is false, then we'll continue. If this is true, then we print this statement and we're done. And we're done with this whole structure. Right? But if this is false, then we'll check the second expression and see if this is true. If that's true, then only this is executed. And if both of these are false, then we'll skip down to the else, and then it'll catch all, and finally this will print. So only one of these will print it at any time. Only one can print, and then afterwards, the next line after this whole structure is printed. So what do you think is going to be the result of this? Which line do you think is going to be executed? All right, let's have a look. Let's enter our Python interpreter. Let's paste in our code and see what happens. A5 is greater than B, which is 1, right? So in the beginning, we set this construct might be a little we haven't talked about this before, but here is our assignment operator. So on the left we have the assignment variables are created and assigned, and on the right we have the values. So this is actually a tuple, and they're deconstructed so that 5 goes into A and 1 goes into B. So this is the same thing as saying A equals 5 and B equals 1. So if we run this, if A is less than B, right? So if 5 is less than 1, no, that's not going to happen. So it's going to go here. If A is greater than B, 5 is greater than 1. So this prints out. This is introduced in Python 3.6, F strings. Love the F strings. So this looks in your locals dict for different variables. And you can see A is 5 and B is 1. So if A is greater than B, then prints this, and that's what it does. It prints A, then the variable is greater than B, and then the variable B. That's all inside of this quote. So it's a shortened syntax for printing values inside of strings. So conditional expression syntax is a bit different than C-based languages because the Python designers wanted to make the syntax easily readable. Right, so foo if A is less than B, else bar. Does that make sense? Let's try it. bar. Foo if A is greater than B, else bar, and prints foo. So we print foo. This is saying print foo if A is greater than B, else bar. Another way to say this would be if A is greater than B, print foo. Else print bar. But this is a lot shorter. So let's create some loops with while and for. While and for are two fundamental types of loops. Let's first look at the while loop. So we're going to start a simple Fibonacci series. And a Fibonacci series is the sum of the two elements defines the next set. Alright, so again we see this deconstruction here. A equals 0 and B equals 1. So while B is less than 50, we start our loop. Right? So before we had the if statement and a colon, and now we have a while statement and a colon. And again, we have an expression in the middle. So expressions are evaluated. So while, the interpreter will evaluate this expression. So B starts off as what? B starts off as 1. So while, so the first time it goes through, it will evaluate while 1 is less than 50, and it is. So it will enter the loop, right? So the first time it comes through, it will enter the loop, and it will print the 1, and then it will set A to B and increase B by A. Right? So after this statement, A will now equal 1. Because A starts off as 0. But now it's setting A to B. So now B starts off as 1. And now after this, A will equal 1. And B will equal A plus B. Let's try it. So A, at the end, A is 34 and B is 55. So we go through the loop. First time through, if 1 is less than 50, it will print the 1. And then it will set B to be, well, 1 again, because 1 plus 0. Second time through, B is still 1. And it has 1 plus 1. Because A is also 1. Third time through, it prints off the B is 2. And now adds the 1 from, which is A. So now it's 3. And it continues like this until A is 55. And it says while 55 is less than 50, while 55 is less than 50. Nope, it does not enter the loop. And now the final time it skips it. So as long as the condition is true, the while loop will continue to execute. Indentation after the colon indicates that the code is part of the loop. Now, for loops. For loops work with an iterator. And actuality, it's an iterator expression. And iterator is an object that each time you call it, it gives the next value. Below code opens a file and called lines.txt and prints the lines in the file. fh is the file handle, and the method readLines is an iterator function. What it does is it takes one object at a time from a sequence of objects and returns those one at a time. So each time the file handle .readLines function is called, it will put the next value in the line variable, which is the next line of text. Let's see it in action here. All right, as you can see here, we are executing this open function. And we can let's look at it. Let's say open. So open wants a file handle, which usually it's a string. You give it the name of the file. And you can also give it the mode for reading or writing. Reading, it will assume read mode if you don't tell it. You can tell it the encoding of the file. It will make assumptions. But basically, we want to tell it the name of the file. Alright, so here we go. We're going to try to open it. Oh, FH is not defined. Alright, so now when let's try to define it. Oh, if we try to define our handle, it says no such file or directory, lines.txt. Alright, that's fine. So, files do we, let's see, let's see, we have, let's create a new file here. Lines.txt, and we will, let's edit it. Let's say the first line is line, let's be creative, line number 1, and then line number 2, and then, you guessed it, line number 3. Alright. Cat is like print, the contents of. So there's our 3-line file. Alright, so now lines.txt should exist. Now if we go to Python and we type in, let's create a file handle, and we'll call open for lines.txt. Alright. So FH is now a text.io wrapper. So we can say for line in fh.readLines, which is our iterator. There's our colon, so we have our expression in the middle, and our expression actually is an iterator expression, so this will evaluate to an iterator. This is an iterator. So let's print the line. Alright, so if we wanted to be fancier, we could say print the line, and now
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Now the end is, instead of a new line character, because this is, the default is this. So we need to, so why didn't that print anything this time? Well, because our iterator was expired and we went to the end of it. So now if we try to call next on it again, it's already at the end. So we need to open it back up again. We create a new object. We could just reset it though also. Right. So let's run it again. And this time, instead of bringing a new line at the end, let's just print our lines. Because the file already has new lines at the end, so we don't want to be too redundant. Alright, so all Python functions return the value none unless there is an explicit return statement. So a return statement, once executed, immediately terminates the function, even if it's not the last line of the function. So if we had this function here, square, you pass it one variable, one positional argument, then we can call it with, this will call it with the value of 10, and it should print the result is this. All right, so as we learned before, we can use f strings. Maybe we can clean this up a little bit. So the result of, let's convert 2 square to a string. Okay, let's first print it like this. Should we? Just to see what we got. All right. I don't want to get too confusing here, but all right. So let's put this in our interpreter and see what we get. Shall we? Okay. So now, do we have our square function? Okay. So we can call square of 10. It's 100. So 10 squared is 100. And negative 1 is 1. Negative 0.234. That squared is 0.05. Okay, so let's set 2 square is 10, right? So we basically did this already. So let's say the result equals square of 2 square. Now what's the result? Result is 100. So let's take our print statement again that we typed in. What did we type in here? We typed in print, the result of is string of a result. Valid syntax. Well, we are using Python 3, so we should be using, remember, Python 2 was a statement, but Python 3, print is a function. So you have to use parentheses with functions. Right, the result of 10 squared is 100. Now how can we clean this up a little bit? We can say the result of, we make it an f string. We pass in our variables. Everything is within the quotes. Squared is and it will make all these strings, even though we're dealing with integers here. Alright, so don't forget to terminate your f string. So it's just a little cleaner. F strings are a little easier to understand. Make Python even easier to read. Alright. So moving on. Sometimes you need a way to shortcut the loop or break out. You can do that with the continue. The continue right here. So if, alright, so we say S is a string, and a string is a sequence. It is also iterable. So you can iterate through S. Say for C in S. So C in S. This is the for loop syntax for iterating. This needs to be an iterator. This is another keyword, and this is the variable you're defining. So every time you iterate through one character through the sequence S, which is one character at a time. So the first time through, C will be T. The second time through the loop, C will be H. Third time through, I, S, space, and so on. So the first time through, C is what? T. So it says if C equals S, no, C is not S, C is T. Then it will continue, but that's false, so it will go to the next line. So we will print C. Second time through, H is equal to S, no, so it will print H. Third time through, print I. Fourth time through, if C equals S, that's true. Fourth time through, C, this is true, so it will go to the continue, which means it will go right back to the for. It'll skip everything afterwards. Let's see it in action. Right, so it's skipping all of the S's, isn't it? All right. S is a string. For C and S, we're going to check if C equals S. If it is, continue. And if not, we are going to print it out. There we go, skipping all the S's. Break also terminates a loop. Where continue will go back to the next iteration, break will break out of the loop completely. Alright, so what do you think this is going to look like? What's your guess? What's this going to do? THI, and instead of skipping the S, it just terminated the whole loop and broke out of it. Okay. Generators. Generators will help you expand your mind. They are one of the more difficult topics in Python, and even Guido has a little trouble with them, he says. And when you get into async programming with async generators, you're really going to be able to blow your mind, because generators are very powerful. A lot of programming languages have them. So they're like functions, except they have a yield statement. So the yield is like a return. It returns a value, but the next time the function's called, it continues after the yield. So in the following code, we're going to look at generator iterators. All right, so returning generator iterators with the yield statement. All right, let's define a function, and we will call it, well, we're defining two functions. All right, so one function is called isPrime. The next function is called primes. And you see, primes contains this yield. So there's no yield over here. This is a regular function. And we haven't talked about functions yet, but this is how you define a function. Def. D-E-F. The same like in, we had our for, we had an expression, and we had our colon. When you define a function, you give it the function signature, and then you give it the colon. All right, so this is a function definition, and we begin a new block. That's the function body, the block. And now over here we have another function we're creating. But this function actually contains, see how we're unindented here, so this for down here is not part of the function. The function body only exists while we're indented. But you can see this function, here is the name of the function, primes. There's our definition of it. So this function contains a yield. So the lexical analyzer, when it's running through all your code before it gets interpreted, it will define this as a generator function, a special type of function. So when we call it down here, let's try it. We're going to see how it works. All right. So we've defined our two functions, is prime and primes. Now, what do you think this is going to look like when we call it? We're going to create a loop, and this is our expression, which is an iterator, because we're calling an iterator function, which happens to be a generator. And then we begin our block, and we say if n is less than 100, we're going to break out. So we're going to basically list the first 100 prime numbers. All right? Because if you haven't noticed, is prime is a function what's given, here is all of the parameters. It only has one positional parameter, n. So given the parameter n, we're going to check if it's equal to 1, then we're going to return false, because 1 is not prime. Okay. And then this function will exit right there if that's true. If it's not true, if n is not 1, well then it will continue with the rest of the function body. So it will check, in a for loop, it will loop from 2 until n. So, and we'll check if it can be divided. It will check if it can be divided by x if the remainder is 0. So this is if the modulus of this number is 0. Checking if it's divisible by anything other than it's, if it's not 1 and it not including itself. If it's divisible by anything, if it has no remainder when it's divided, then it will say nope, it's also not prime. So if it's 1 or if it's divisible evenly, then it will return false. It's not a prime. Otherwise, it is a prime number. All right, so that's this function. So in our main body here, we're calling primes, which is our generator function, remember, because it contains a yield. We're calling is prime. So we're starting off at 1, and we're saying, while true, we're beginning this big loop here. This was called an infinite loop, while true. It never exits. So infinite loops are normally a bad thing, but in generators, we only execute this one time, the first time, because the execution actually stops the yield. So when the function, the first time it's called, it will come through. Of course, this will be true. It will call is prime on 1, and is prime 1? Is 1 prime? Does prime 1 return true? Or what evaluates to a Boolean true? Does anybody know if 1 is prime? What do you think is going to happen? Well, 1 is not prime. So it will not get to this. It will go to n plus 1 and go back up to the loop, and we'll say if.
Thanks for watching. Please like and share this video.
If is prime 2, and 2 is prime. Nothing else, this is not true. So it will yield 2. 2 is prime. But then it will stop. After it yields the 2, it stops. So the first time it comes through, if n is, first time it comes through, n is 2 now. So if 2 is less than 100, well, if 2 is greater than 100, then we break out. So 2 is less than 100, so we're not going to break out, we're going to print. And then we're going to start back up here at 3. And we're going to check if 3 is prime. If it is, we're going to yield second time through. That's a brief overview. Let's see what happens. Well, there's our 2, 3. Now 4 is not prime, so it didn't print 4. But it got all the way up into, so let's call next on, can we reuse our primes? Let's call next on primes. Oh, why can't we call next on primes? Function object is not an iterator. Oh, it's the function, right? So if we type primes, it's a function. So we have to call next on primes. So every primes was not defined right, actually, because it's always, first time it's called, it's always 1. So we can't reuse this particular implementation. We cannot reuse this. All right, so what is the type that returns from primes? A primes call. It does give us our generator. So we know that for statements can loop over list characters, dict keys, etc. Any sequence, any iterable. These are called iterable objects. The built-in iter function takes an iterable object and returns an iterator. So you can call iter on anything, and it makes it an iterator. Even though a list is iterable, it is not an iterator, so it doesn't have a next. So you can call next on an iterator of a list. So the assignment for this session is to write a conditional program with for and while loops using some of the iterable objects we've talked about. All right, so that was flow control constructs. And in the next session, we are going to talk about expressions. All right, so thank you very much. Hello, and welcome back to Coding Bootcamp's Introduction to the Python Programming Language. Last session we talked about expressions, and well, we know we talked about flow control structures, and this time we're talking about expressions. So let's get to the overview. The objectives of this session are talking about unary and binary arithmetic expression operations, comparison and Boolean operations, conditional expressions, as well as lambda expressions, and the order of operations and operator evaluation, talking about expression lists, and finally assignment operations. Now these things we've all used before, but now we're going to get deeper into the discussion. So we've seen expressions And pretty much everything we've done so far has been an expression. And it's the fundamental building block of language like Python, higher order languages. Most statements that you write will contain expressions. A simple example of an expression is 2 plus 3, for example. An expression can be broken down into operators and operands. Operators are functionally that which do something that can be represented by symbols such as plus or by special keywords. Operators require some data to operate on, and as such, their data is called operands. In this case, 2 and 3 are the operands, and plus is the operator. Assume that we have two variables in Python, a with the value of 4 and b with a value of 2. So here let's talk about the basic arithmetic operations that can be performed on these variables. Addition adds the values, subtraction subtracts, multiplication, division, modulus, and exponentiation. Same as mathematics. Unary operators in Python are just one operand and return a result. So the plus and minus binary operators can also be used as unary operators when the operation is performed on just one operand. So if we have a equals 3, then we have, instead of 2 plus a, there's nothing here. So this plus is a unary operator, as this is also a unary operator. A Boolean expression evaluates to one of two states, true or false. Python provides a Boolean type that can be used either to set to true or to false. Many functions and operations have Boolean objects. The not operator can be used to invert the Boolean type. In other words, convert it from true to false or vice versa, for example. Every object can evaluate to a Boolean value. The following evaluate to false. The false object. Let's take a look at these as we do them, can we? False evaluates, so we can say bool false evaluates to false. Bool of none evaluates to false. Bool of 0 is false, 0.0. Empty collections, like empty string, also false. Empty list, false. Empty set, false. Also objects that have a non-zero or len special dunder methods also evaluate to false. Special cases in classes you can specifically evaluate to false, and pretty much everything else evaluates to true. So 1. So let's try the Boolean of 1. That evaluates to true. Boolean of, let's say the Boolean of list, that will be false. That's the same thing as list. But if we have something in the list, that evaluates to true. Let's say a set, or a tuple actually. We can have a none. Well, let's say a string with a value. That evaluates to true. These operators below compare to the values on either side and return either true or false. equal comparative, not equal comparative, greater than, less than or equal to, greater than or equal to, and less than or equal to. So what's the Boolean of 1 equals 1? 1 equals 2? 1 is not equal to 2. Well, that's true. 1 is greater than 2? No. But is it less than 2? Yes. Less than or equal to 2? Well, still yes. And greater than or equal to 2? No. No. Is 2 greater than or equal to 2? Well, that is true. Conditional expressions in Python are used to perform different actions depending on whether a condition values are true or false. We've seen this. If condition 1, statement, block 1. Elif condition 2, block 2. Else, the third block. Remember, we've seen that from the last session. Lambda expressions, the bane of Guido and other lambda haters. Either you love them or you hate them. You don't need to have lambdas in your function. And Guido van Rossum, the benevolent dictator for life, the creator of Python, hates lambda expressions. Lambda functions. The lambda function is a way to create a small anonymous function, in other words, a function without a name. These functions are throwaway functions that are only needed where they are defined. The general syntax is lambda, the keyword lambda, followed by an argument list, a colon, and an expression. So let's take a look. This lambda function is the sum. It's basically a sum. So you could pass it anything you want. Let's try this out and see how it works in our terminal. So it does add those two together. 1 plus 2 is 3. 1 plus negative 1 is 0. 1 plus negative 1.5, negative 0.5. So we could also set the variable f equal to our lambda, and then we could call f with 1 and 1, and we get our 2. 1 and 2, we get our 3. 1 and 22, we get a 23. So remember, the lambda is just lambda functions are just another way to define a function, a simple way. You could also say define f this way. It takes a and b, and you return. Well, let's keep it consistent. That's not very pretty, what I just did. So let's say I wanted to use the same parameters, so x and y. So we can say return x plus y. So f is a function. Now we can call f with 1 and 2. Same thing. We could actually call this sum. Sum equals f. So now we can, it might be a better name to use sum. The sum of 1 plus 1 is 2.
Thanks for watching. Feel free to add your questions as comments down below.
Now, the order of operations is important, just like in mathematics. As a matter of fact, Python uses the same rules as mathematics. Parentheses have the highest precedence, exponentiation, two multiple signs, and then multiplication and division, and finally addition and subtraction. So in algebra we say it's left associative because in this expression, 6 minus 3 plus 2, the answer is 5, not 1, because 6 minus 3 plus 2 is not the same as 6 minus 3 plus 2. The assignment of operators are used in Python to assign values to variables. Let's look at a equals 5. It's a simple assignment operation that assigns the value 5 on the right to the variable a on the left. Here is a list of operators in Python and what the equivalents are. Take a look at those at your leisure. And the assignment is to use them in a program. All right, so that was expressions. Next time we're going to take a look at expression handling, exception handling. Sorry, exceptions are errors. When something bad happens, we want to be able to catch it and know what happened. So join us next time for exception handling. All right, that's it. Thanks. Hello, and welcome back to Coding Bootcamp's Introduction to the Python Programming Language. Last session we did expressions, and now in this session we are going to talk about exception handling. Let's get to the objectives. Let's talk about types of Python exceptions, handling them with try, except finally, how to trigger them with raise, how to define new ones, and how to implement exception handling. Finally, let's give a working example with regular expressions. So, what are Python exceptions? Well, when something bad happens, we need to know about it. So, Python lets us know via an interface called an exception. And you can see a whole list of them at python.org. Let's have a look. Built-in exceptions. We have base classes, the base exception, regular exception, and a couple other ones. Look up here. And the other ones are based on those exceptions. So we have assertion error, attribute error, end of file, floating point error, general exit. You can't import something, maybe because its module's not found. You try to index something that's not in the list or not in a dict. Control C, you'll get that. Oh, you don't want to get that. And file not found and different things. Those are the basic exceptions. So it's good to work with Python standard ones because other programmers will recognize what you're doing easier, and it's easier to integrate with other libraries, and also you won't have to write them. But like we said, you can create your own. So exceptions are the main way to handle errors in Python. If there is an error in the program, it dumps a stack trace and an error message, and those error messages are simple uncaught exceptions. So you implement exception handling with the try statement. So you issue the try statement, and then a block begins because you have your colon. Block is indented, one or more spaces. Standard is 4 spaces. Then you list all of your lines where you think you're going to get an error, and then you list all of the exceptions you think may trigger it, may get triggered by this code here. So, for example, this exception IO error will get triggered if there's an input-output problem. For example, the file doesn't exist. So if that error is triggered, then you'll print a message. You can do anything, print anything you want here. The message is, the error is caught in this variable E, so you can print that out as well. And if nothing else happens, nothing bad happens, you can use your variable that you defined, or you can do anything else. And finally is used, this code will always execute, even if this causes perhaps this causes an operating system error, or maybe this causes a sig fault in your execution runtime. This code will always be executed. That's the theory. So let's try this and see how it works. Let's run. Let's get a little closer. Let's run Python. Let's run Python. Let's type in our code, see what happens. Whoa. So we could not, it says could not open the file, which is curiously the same thing we have here. And then after could not open file, it prints our error that we caught. Could not open file. And then here's our error we got from Python. Error number 2, no such file or directory. We couldn't find a file called file name. And then we see executing finally. So we're, even though we got an error, it still executed this. This code never got executed. So let's try to, well, we can create a file called finally, or we can let's say open file name for writing, and then we can write line we are getting it. No object write line. Oh, what language am I talking about here? Right? A bytes object is required, not a string. So 17 bytes written. And now let's try to execute our code. See what happens. Well, it looks like we opened our file, but this time we did not get an exception. Instead, it looks like it executed the else and it actually printed a line. Stripped off the new line character at the end. Well, I didn't even have one actually. So you recognize the for statement. The for loop, it's a loop actually, it'll go for each line inside of our file handler we opened up. And then finally it printed executing finally, of course. It worked. Triggering exceptions with raise. So you can use the raise keyword. And looking briefly here, this is a function, this is a function, so the main line starts here at this if statement way at the bottom. So if this is standard, you don't have to know what this means, but it's Python we've already learned is an if statement. The name is if you're running the code not in a library, then you'll be running the main. The name will be main that you're running. So if it is, then we run this main. So this is how you get around executing code in a module if it's just being imported. So only if you are running it do you want to execute this main code. So that's what's going to happen. That what I just said has to do with module importing, which you don't really have to know yet. We haven't covered that yet. But we're going to try to read file on xlines.txt, and then we're going to print the same thing we just did, basically, and capture exceptions. And finally, so in this read file function we've defined down here, we accept the file name and we say if the file name ends with .txt, then we're good. Otherwise, we want to raise a value error and tell the user, which may be another program. If this is a library, we may want to tell the user must end with .txt. So like we said, we can define our own exceptions. We inherit from the base class exception, which we saw from python.org. And we can also, multiple inheritance and create our other exceptions. So we want to implement those. We can define a function here. My function. We check an error condition and we raise my input error if it's true. Or maybe we want to check for a different error and we could raise another error. If we don't get either of these two errors, we can return success to the user. So if we're going to call my function, right, there's our definition. Over here, we can find out how to call it. And so we can try to print my function, give it some arguments. And if any error condition happens, we may get an exception. Like, for example, my input error. And then we can print that off to the user. The last thing we'll talk about is working with regular expressions. And as an example for exception handling. Regular expressions are a powerful language for matching text patterns. We saw them in a previous session. The module RE provides full support for regular expressions in Python, and it raises the exception re.error if an error happens by compiling or using a regular expression.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
In Python, a regular expression search is typically written as the variable equals the re.search, and you give it a pattern and a string to look in. So let's take an example. If we have this string, let's try to match using this pattern, which is WRD colon followed by 3 words. All right. So if we get an error, we can raise the error to re-raise it to, and then make sure we capture. We could massage it if we wanted to, or else we check if we got a match, because maybe it's not an error, but it just didn't match. For example, we could get an exception if this was not a string. Perhaps it was an integer. We get integer error or type error. So if everything's fine, no exceptions, this could be blank if it didn't find this. Regular expression didn't match. Well, then match would be none. So none evaluates the Boolean false, so it would not print found match cube. Let's try this code and see what happens. All right. So it found the word cat. Right. 3 letters. Word letters. Letters. The assignment is to use try, except finally, and raise in a program. But that's it for today. Next time we're going to come back with using the string object. And we're getting close to the end of this class. Only a few more left. So join us next time. That's it. Thanks, guys. Hello, and welcome back to Coding Bootcamp's Introduction to the Python Programming Language. Last time we looked at exceptions, and this time we are going to be using the string object. So let's get started by taking a look at the objectives of this video. We're going to be using ASCII and Unicode strings, manipulating them with the string methods like format, and taking a look at some escape sequences and how to print them with raw strings. In Python 3, all strings are sequences of Unicode characters. You can take a string and turn it into a sequence of bytes in a particular character encoding and vice versa. We can do that in a for loop, decode our lines as we read them, maybe if we have a Chinese email or something. And the cur function turns a character, given its ASCII value, will return a C. Cur99 returns C. And the ORD function is the opposite. If you give it a C, it'll tell you the ASCII 99. Strings are objects, like everything in Python's an object. If we assign a string to a variable, the variable contains a reference to a new string object we just created. So everything that you can do to a string reference, you can do on a string literal. say s.upper, or we can actually take the string and call .upper on the string, literal. String objects support a lot of methods. As you can see here, s.capitalize, swap case, upper and lower we use a lot. You can find a string within a string. You can also do replace, search and replace. Replace this with that. And it's important to note that a string is immutable. So the string is not changed when we run these functions. It's not changing the string. What we see when if we type in the string and call s.capitalize, what we get back is a new object. S is not changed at all. Python's format method on the string object allows you to do variable substitutions and formatting. It lets you concatenate elements together within a string through positional formatting. Formatters work by putting in one or more placeholders, defined by a pair of curly braces, into a string and calling it the format method on the string. We can also assign the string with placeholders to a variable. So in this case, here's our string. This is the placeholder right here. This is not a dictionary. Inside of a string, it's a placeholder. So we call the format method on the string, and we give it enough arguments here to fill out all our placeholders. We make sure you have the right number here. Not too many, not too little. So after we run this, the format method will return back to us a new string object. Sammy has 5 balloons. So we can also, like we said, put this string with the placeholder in it, and then just call the format on our variable. We pass it our balloons. Sammy loves balloons. Now, if we want to look at another way to do it, remember we talked about it earlier, the formatted strings that we got released to us in Python 3.6. We can say, for example, F strings. They're called F strings. So we can say F strings. We say Sammy loves balloons. Now for this to work, we're going to need to have a variable called balloons, because it's going to look in our local variables for something called balloons. So balloons equals, let's say, red balloons. Not so creative, but now we can see Sammy loves red balloons. Alright. The backslash character is used to escape other characters in a string. So if we want to print a new line, we can do \n. But if we actually want to print a backslash character, or a quote character, for example, inside of a string, we can use a raw string. We also saw this in a previous session. So here are the basic escape sequences. and what they do. So a backslash at the end of a line, as we saw, is what does what? It joins the lines together into a single logical line. So 2 backslashes will print out 1 backslash. You can backslash a quote if you're inside of quotes. Maybe we can look at these. Right, so we can say this is a single logical line, separated onto 2 physical lines, as we see. Alright, so if we want to print a backslash, we can give it a double backslash. Right, we can, if we wanted to print a quote inside of here, we want to print a quote, we can backslash that quote so the string will not end there. We can say, hey, here's a quote. Now, what do you think is going to happen if I type this? Anything going to happen? Yes. Syntax error. Why is that? Because I forgot to escape this quote. Right. We can, same thing with double quotes. We can print a bell. Did you hear anything? I did not. We can print out a backspace. So let's say we can print out X backspace, XY. So we can print out A, B, C. Let's just make it make sense. So our C gets written over with a backspace there. A form feed. Yeah, extra line there. Pretty much the same thing as a new line. I think line feed is Linux. And a carriage return /r/n is what Windows uses. Carriage return is from typewriters, which move the carriage all the way to the first position. You can print a horizontal tab. And a vertical tab. Let's see what that does here on the. Oh yeah, vertical tab. Interesting. Alright, if you want to create a string that contains backslashes and you don't want Python to try to interpret the backslashes as escape sequence, and you don't want to prefix them with a backslash, you can create a raw string. To create a raw string, specify an R character before the opening single quotes. We also saw this in a previous session. So this should be nothing new for people who've been following along. The assignment for this session is to write a Python program and use string functions, including the format function. Alright guys, so next time we are going to pick up with organizing our code. Alright, so that's it for this time.
Thanks for watching. Please like and share this video.
We will see you on the next one, guys. Thanks. Hello, and welcome back to Coding Bootcamp's Introduction to the Python Programming Language. Last time, we talked about using the string object, and this time we are going to cover organizing code. Right? What that means. So, without further ado, let's get into the objectives. In this video, we're going to define some functions, call them, create some anonymous functions, and decorators. We're going to define some classes and instantiate some of them. Use inheritance for pre-existing classes. Then organize our code with modules and packages. So let's get into it. We don't want a 500,000 line Python program. We organize our code in various ways, and probably the lowest level is functions. So you take a group of related code, organize them into a function, and then in the main part of your program, you just have a one-line call to that function. Now that function may be 1,000 lines, but you can use it in multiple places. And even if you only use it in one place in your program, it's organizing it so you just see in the main part of your program the single line to call it. So the lowest level, we can define functions to organize our code. You can define functions to provide functionality by using the def keyword, DEF. And then you put the function name, your parentheses, and a colon. We know about the colon beginning blocks from our previous work with if statements and for loops. This is similar. We're going to see this in a minute. Then you put any input parameters and arguments inside the parentheses. And the first line of your function could be a string, just a string, and that will be what is called the doc string. We're going to look at that later. Then the function body is indented after the colon, just like other for suite, while loop. And then at the end you have a return statement, or actually anywhere in the function you can have a return statement to exit the function. And if you don't have a return statement, it will automatically return none to the caller. None is a special Python type, special object. So here we see a function defined. If the function is called printMe, and it accepts a single argument, and then it prints it, and then returns. So we have the DEF, the name of the function, our parentheses, and inside we have our arguments. It could be a this is not a type, this is a string. We can call this anything we want. Name. We can give it more arguments. Age. As many as we want. And we don't want to skip to the end, do we? Just yet, do we? Okay, so how do we call a function? We define a function And once the basic structure is finalized, you can execute it by calling it from another function, or directly from the Python prompt or the body of our code. We can call the printme function by using the name and the parentheses. And it does accept one argument, so let's have a look really quick. And can we, let's see if we can put this in our interpreter. Let us run Python. Let's type this in. So now we can see print me. Is a function. And if we try to call it, it says, oh, we're missing one required positional argument. So it's looking for a parameter called string. So let's try it again, and this time we'll give it an integer. So it doesn't matter if it's not a string. The string is not a type, it's just a name. So there we can see that it prints the string passed to the function. It printed that. And then it printed our string that we passed it. Right. Maybe we want to try calling it. Let's see if this actually works. Well, that looked like it worked. Let's pass it with this second argument. Yep, looks like it's all working. So creating anonymous functions. Functions are called anonymous if they are defined using the lambda keyword and not with the normal def keyword. They can take any number of arguments, but the function body can only contain a single expression of which the evaluated value is returned. Okay, so we looked at this before. We used lambda functions in expressions, chapter 5. Decorators. Altering functionality with decorators. A decorator is a function that takes another function and extends its behavior without implicitly modifying the code. So let's talk about some aspects of a function. First, we can assign multiple names to the same function. So here's a definition of a function. Let's have a look at that. Yep. So sucks is a function, and if we call it, we pass 10, it returns 11. Now we could say x equals suck, and we could say x sub 10, and x sub 100, x sub 1.2. Looks like it's working. Next, a function can be placed inside another function. So that's called a nested function. One function inside of another function. Here's an example. Here is our f function. We have a function called f. So we use def. There are no parameters inside the parentheses. And here is, after the colon, we begin the body of the function. Here's the body of the function. First thing it does, it defines another function inside of itself. So that's g. So at the end of the function f, we are printing and calling g at the very end. So the output looks like this. So first, this is our function definition. So our main line begins here. And all we do is we call f. So first thing f should do is it should go here. First thing f actually does is it defines g. But the first thing we'll see is it's going to print, this is the function f. Then it will say, I'm now calling g. And then it will actually call g. And it says, hi, it's me, g. Thanks for calling. Okay, thirdly, a function can be passed as an argument to another function. So our main line here is we are calling f, but we have a new definition for f. So we're going to call it, and we're going to pass it g. And now g is actually a function. So in Python, functions are first-class objects, which means you could pass them around just like variables. Now notice we passed g. We didn't call g. We didn't do this. We didn't do this deal. We're not calling g and passing in the result. We're actually passing the reference to g to f. So f will receive a parameter called function, func. It'll say, hi, it's me, f. I'm going to call func now. And then it will actually call func, which is the function it received. Whatever function you passed it, it's going to assume it's a function, and it's going to call it. So it calls g and says, hi, it's me, g. Thanks for calling me. Next, functions can return references to function objects. Okay. We're getting closer to deal with our decorators here. So now f is defined as such. It defines g inside. And now f will return g. So when you call f, what you're going to get back is a reference to another function. Here's the function g. So here is our main line. We are going to call f, and we're going to store the value in nf1. And nf1 is going to have the reference to a function g. So we can call it. We're assuming that we're getting back a reference here. So we're going to call it. So this is calling the same thing as calling g. And it should say, I am inside function g. So now we can use all of these concepts to create a decorator function. All right. Now here is our decorator function. Now if you return a function, just like we saw the last one returning g, we're returning function wrapper, which is defined here. There's our function wrapper. So when we call our decorator, we're going to get back.
Thanks for watching. Feel free to add your questions as comments down below.
This function reference. We're not calling it here. There's no parentheses on the end here. So we're not calling it. Our decorator merely returns the reference to our function wrapper. So if we have a function reference returned from a function, we can use that function this one, our decorator. We can use it as a decorator. What we do is we precede it with an @ sign. And that becomes our decorator. So when we call foo, here's our function foo, right? Which is decorated by our decorator function. So when we call foo, it's going to expect a value. So we'll pass it 42. So this should say, hi, foo called with, or whatever it's called with 42. So where did this come from? Decorating the function foo. Now, function foo is decorated by our decorator, and the decorator returns this wrapper function, and the wrapper function could expects this, which it gets as 42, and we could do something with that. So let's try it. All right, let's see what we get. All right, our decorator is a function. All right, now let's define foo, and we define it as decorated. So now let's call foo with, let's try 42. Decorating foo. Now, if we want to change our decorator at all, we can, let's say we can do something, decorating foo, we can do something with x. Let's define, when we print decorating foo, let's print our x that we got back, right? Let's print it out. So let's call foo 42. We have to redefine foo. So we changed our decorator function, but we didn't redefine foo with this new object, so that's why I had to redefine our decorator. We had to redecorate foo. So now it says decorating foo 42. So we can actually do something with 42. If we wanted to, let's say we wanted to increase it by 1. Right? So we could say our function wrapper receives 42 it says decorating 42, and then it will call our function with 43. Let's see what happens. So we're decorating 42, but now we're pretending that foo got called with 43. Right? We could say 1. We could say negative 1, 2, 3. So we can use decorators to change our values. So like we said, it changes the code, it changes the function without actually changing the code. But the actual function behavior is changed. So a class is a user-defined prototype for an object that defines a set of attributes that characterize any object of the class. So we use the word, this is a keyword class, we give it a class name, then our colon, which starts a body. The first line, just like functions, can be a docstring. And then we begin our class suite, our body. So let's define a simple class employee. We can call this anything we want. There's our docstring. So let's have a look. Can we type this in? Oh, it probably won't like it because too many spaces. So let me just take the spaces out. It makes it easier to cut and paste. So now, class is that's not right. Class is employee is a class. All right. Employee is a class. So now we can say we can look at the variable count and see that it's a class variable. It's defined directly on the class itself. That's called a class variable. So all instantiations, all objects, all employee objects share this single count. And then we see the init method, the special constructor that accepts two parameters, name and salary. This is how Python gets a self-reference. You can call it anything you want, but everybody uses the word self here. And Python will automatically load this parameter with an argument to point to itself. So let's create a couple of employees and see what we get. So this is employee is a class, but now emp1 is an object, an instantiated object from the employee class. All right, now if we type in employee.count, we have one employee. So now we have two employees. All right. And so we access our attributes and methods with the dot notation. You can, emp1 dot display employee. Right. In object-oriented programming, inheritance is a way to reuse code from existing classes. You can make a derived class, a subtype, a subclass. So a subclass inherits all the attributes of a parent class. And we can also create new attributes and methods inside of the subclass. And we can even override some of the parents' classes. So let's see that in action. All right, if we have a parent class and we have a child class, then we can inherit from the parent class. And we have our parent class defined. And we have our child class can also be defined. All right, so parent, child. Now, if we call we can say C equals child. All right, so it says we called the child constructor. Now we have init here. Dunder init, as it's called, is overriding dunder init from the parent. As you can see, we define the child class with the keyword class, the name child, the name, whatever we give it, child, and then the base classes. So we're inheriting from parent. So we have all of these attributes inside of here. So, but we're overriding this method from the parent. So you can see it doesn't say calling parent constructor, it just says calling child constructor because we overrode it here. So let's see if we can print off our parent adder. Oh yeah, it's 100. All right. And we can call child method, calling child method. We can call, now can we access parent methods? Okay, calling parent method. Now let's set our parent attribute to 200. All right. And now let's get attribute. So now the parent attribute is 200. Huh. So we changed it in the child class. How else can we organize our code? We can use functions. We can use functions inside of classes. And now we can put classes inside of modules. A module is a file consisting of Python code. It's a file. Module is a file. It allows you to logically organize your code by grouping related code into a single file. So a function contains code, a class contains functions, which are called methods.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
And a module contains classes. So this makes it easier to understand and use. An imported module is a Python object which has attributes you can bind and reference. A module can define functions, classes, and variables. A module can also include runnable code. To be careful with that. You can use Python source file as a module by executing an import statement in another Python source code, as long as the file we're importing has an init.py file next to it. So how we import it, we say import and then give it the module name. We can give it as many as we want. So a search path is used in its search to find the modules. We're going to talk about that. We're going to talk about this directly. So locating the search path. When you import a module, the Python interpreter searches for the module in the following sequence. First, in sys.modules. If you already imported, it'll be in sys.modules. Otherwise, it'll look for its own built-in modules. And if not, it'll look for a module in the directory of the init script, or the current directory if you're in the interpreter like we are. If not found anywhere of these three, then the fourth option is to look at the Python path environment variable. That should be a string to tell it where to look. And if all else fails, it will be the installation dependent default. Like on Linux, it'll be user local bin, or it will be different depending on your operating system. Using packages to group modules together. Now, code sits in functions. Functions sit in classes. Classes sit in modules, and modules sit in packages. So a package is a hierarchical directory structure that defines a Python environment consisting of modules and subpackages. So modules are files and subpackages are just subdirectories. So consider this directory structure. Here's a directory called phone. And inside of it, there's 4 files. So we have, in the phone package, we have 4 modules. Init.py is a special module that gets imported whenever we import phone. It's automatically imported. And we just reference it with the phone namespace. So we can define functions inside of our modules. So let's say inside of the G3 module, we define a function called G3, and so on. All right, let's look at that. Now, to make all of your functions available when you import phone, we're going to want to import them automatically. We can. You don't have to. We can automatically import them from inside of our init.py file. So let's look at, we have our phone. All right, so PyCache is our cache. Once we run things, it creates a PYC file, and then it only has to. It's a compiled Python file. Once we compile them, it puts it in PyCache, and then we don't have to look at them again. So let's the infamous rm minus rf. You got to be very careful, boys and girls, about using this. So let's just get rid of it. All right, so let's run Python. Now when we say import phone, we can look at phone, and now we have G3 is automatically imported, ISDN and POTS is automatically imported for us. So now we can run, for example, phone, and they're all imported to this phone namespace. phone.g3 function. And if we want to call it, well, we just called it. As we saw before, it didn't do anything. It just runs pass. But now we have our functions automatically imported into our phone namespace. So phone is a module, but we consider it, since it's a directory, we call it a package. So the assignment is to write a program that uses a practical use of the decorator function. All right. So that is it, boys and girls. We just talked about organizing our code. And next time we're going to talk about a longer topic: arrays, collections, and dictionaries. All right. So that will be for next time. All right, that's it. Thank you. Hello, and welcome back to Coding Bootcamp's Introduction to the Python Programming Language. Last time, we talked about organizing our code into functions, classes, modules, and packages, and this time, we're going to be talking about containers. So let's get to the objectives. Basically, we are going to be talking about Python's built-in containers, the list, the tuple, the set, the dictionary, and at the end we're going to discuss NumPy arrays. So we've discussed all this stuff before, but this is more in-depth discussion. So a list is an ordered, indexed, changeable container delimited with square brackets. So it's ordered. Whatever order you put them in, that's the order you're going to get them out. It's indexed means you can tell it which index you want and it'll pull it out. Random access, pulling it out. All right, so if we say if fruit sub 0, our 0-based index is apple. Fruit sub -2, this is -1, this is -2. Fruit sub 1, now we can change the list. Lists are changeable. So we can now say fruit sub 1 is mango, which is fruit sub 1. So now we print it out and it's apple, mango, cherry, and orange. We can concatenate lists with the plus operator, just like strings, 1 + 1. We can say our fruits plus this array and so we did have apple, mango, cherry, and orange, and now we have apple, mango, cherry, and orange, and 1 none and watermelon. We can create substrings with the slice notation. So we give it 2 indexes, the from and the to. So this is starting at index 1 and going to index 3 minus 1, that's n minus 1, so that would be index 2. So this is from 1 up until 3, not including 3. So if we don't give it a starting index, it'll start at the beginning. If we don't give it an ending index, it'll start at 0, 1, 2, 3, and go to the end. Tuples. A tuple is ordered, indexed, and unchangeable container delimited with parentheses. That's how you know it. It's just like a list, except instead of square brackets, it has parentheses. So tuples are said to be immutable But if you want to see why they're immutable until they're mutable, you can read this inventwithpython.com blog post from 2018. We already went through this in a previous discussion, and that was under, I think, chapter 2, using Python. Or was it chapter 3, language fundamentals, I believe. So same thing, you can index tuples, index 4, 0, 1, 2, 3, 4. And you can set it to 7. Oh, no, you can't. It's unchangeable. The so-called immutable type. So understanding the difference between lists and tuples. Tuples offer some degree of safety. If we know that something doesn't need to change, then we can eliminate the risk of it accidentally changing, or perhaps a function changing it if we pass it as a argument. And if tuples contain only literals are used, they're much faster to create than lists with the same arguments. So if you run this from the command prompt, load the module, time it, and you give it this string to set it up. You say x is 1, y is 2, z is 3, and you do this 100,000 times, or 10 million. If you run this 10 million times, it will take an average of 0.03 microseconds. And if you do it with tuples, then it's 0.02 microseconds, a little bit faster. A set is unordered, unindexed, but it is changeable. So it's like a list, but you cannot have repeating elements. And we use curly braces just like dicts, but without the keys, just the values. So we can say, well, we can create a set with the built-in set function, and we give it an iterable object, and the string is an iterable object, so we pass it this, and the string is set to A, P, I, so it's not ordered. It doesn't stay in the same order we gave it into it, and notice we don't have two O's, we just have the one O. And if we pass it another iterable, a list, we'll get those three elements in our list, in our set. And if we try to duplicate elements, see, another way you can declare a set is with curly braces. So this is a set. It won't duplicate any items. Now we can run the union. So sets are just like they are in Python, just like they are in mathematics. So these three sets, if we take the union of those three sets, we'll get all of these elements. We get A, we get F. Remember, they're not in order, but they're all going to be there. And the same way intersection, if we intersect those three sets, the only elements common to all of them are D and E. See, this one does not have F. This one does not have C. And also the difference, we can say the difference is from set X. The difference of these two is A, B, C. So these two sets do not contain A, B, or C. but they do both contain D and E. So the difference
Thanks for watching. Please like and share this video.
is A, B, and C. Let's move on to dictionaries. A dict is unordered. Well, that's no longer true. Just realized in Python 3.5, dicts became, with the reference implementation in C Python, so Python written in C, dicts became ordered without any loss of performance. And that reference implementation became a language directive in 3.7. We're now in 3.8, but if you're running 3.7, it's all ports, Windows or Mac or Linux or anywhere else BSD, anywhere else you're running Python. They'll all as in Python 3.7, they are all going to be ordered. So you'll get them back out in the same order you put them in. And they are indexed with a key. And of course they are changeable, delimited like sets with curly braces. So keys can be anything that is hashable. Like a string or integer or tuple, but not a list. A key cannot be a list because a list is not hashable. And the values can be anything. So let's take a look at some examples. Let's set a user equal to name Sally, age 26, marks none. Let's take a look at her name, Sally. There's some iterable methods we can call to find out the items or the keys or just the values. We can also index the dict to find out what value is at the married index for this user dict. So we're going to set it equal to true. Now if you notice, married is not in the dict, but we can add it, and now it's there. So we can use the same syntax to modify. Add and modify, it's the same syntax. So if it's not there, it'll add the item. So married was true, and now it's false. And we can also update the user. We pass it another dictionary. And we're going to change. We can add things this way. We're going to add likes. Likes does not exist. We're going to change marks, and we're going to change married. So now you see marks is now 1. It changed from none to 1. Married is now true. She got married again. And now she has 305 likes. So we can also delete an item. So we want to delete the marks, or we're going to delete the marks item. So marks is 1, but now it's gone. Remember, these are all in the same order we put them in, because I'm running 3.6 with this and the C Python reference implementation. We can also clear out a dict, and it'll just be an empty dict now. If we no longer need a specific dictionary, we can use del to remove the reference from the symbol table, so we no longer have access to it, and then the garbage collector will be able to free up that memory next time it runs. So delete user, and now we can no longer access it. And this is true for any variable. You can delete any variable, not just dicts, lists, or objects, or anything. Alright, so finally, let's talk about NumPy. So lists are very useful. but they're very slow. And NumPy is orders of magnitude faster. I don't know, 50 times faster than list or something. Quite fast. It's a well-known package. It's the fundamental package for scientific computing in Python. It's a fast and versatile n-dimensional vectorized and indexed de facto standard for array computing today. Basically, it's Python list on steroids. NumPy has array functions used to store lists of numerical data. The elements of NumPy are usually numbers, but can also be Boolean strings or objects. Other objects, when the elements are numbers, they must all be the same type. They must all be integers or floats. So there's a number of functions for creating arrays. And the first one is to use the array function. You pass it an iterable, so it'll convert this list to an array. This will convert a Python list to a NumPy array. And that looks like this. And they're all 64-bit integers. And if we pass it all floats, then it will also see there's 64-bit floats. So linear space function will, with the arguments we've passed it, it will create 9 numbers evenly spaced from 0 to 2. Log space will do the same thing. We're going to create 4 log numbers evenly spaced from log 2 to log 3. And we can run arrange to arrange the first 15 numbers. And then on that, we can also run reshape to make it pretty like this 3 rows. Zeros, we can create zeros. The default is float. Ones, we'll create an array of ones. And last, collections. Python's collections module implements some nice data structures which will help solve various real-life problems. So if we import collections, now NumPy needs to be installed with pip, or however you want to install packages. But collections is part of the standard library, so you just go ahead and import it without installing anything. But you do have to import it because it's not a built-in. So we import the collections, and then we can run collections on a counter of this string, and it'll count how many times each one appeared. So we have 3 A's, 2 B's, and a C. Default dict, very useful. The default will be a list. This is the factory we'll use to create defaults. If it encounters them, it will not error out. It will give us a list. So we can create a default dict. There it is. And so it's empty. It's basically that. And we can just say d sub 1 append. We don't have to say d sub 1 equals an empty list and then d sub 1 dot append. We can just say d sub 1 dot append. There it is. We can, so d sub 2, so the index 2 is not in here, but we can reference it. And the default is list, so it gives us a default empty list. And now once we, just by accessing it, we're not assigning to it, we're just accessing it. Now it's in our default dict. Alright, so the assignment is to use all of these things together. And when you use a list, convert your list to a NumPy array. Alright, so boys and girls, that's it. That was it for containers. Next time we're going to wrap up with working with arguments. Alright, so I hope to see you back for the last session. Well, that'll do it. Alright. Thank you very much. Hello, and welcome back to Coding Bootcamp's Introduction to the Python Programming Language. Last time we talked about containers, and now this is the final session. We're going to be working with arguments. That is, function arguments. So let's get to the objectives. We're going to be talking about passing arguments to functions by reference and by value, and variable length argument signatures for functions. So let's get into it. Passing arguments to functions. How are arguments passed to functions in Python? If you pass immutable arguments like integers or strings or tuples, the call by value will be used, and if you pass something mutable, then the reference evaluation will be used. So the most common strategy for passing arguments is call by value, and when the expression is evaluated, the value is bound to the corresponding parameter in the function. So if the expression is a variable, a local copy of the value will be used in the function. In other words, the variable in the caller scope will be unchanged, cannot be changed by the function. But if you pass something that's mutable, Python will assign values to the parameters in the function with the call by reference evaluation, which is the reference to the object you're passing is passed to the argument. So as a consequence, the function can modify the argument, can modify the value. In other words, the value of the variable in the caller scope can be changed. So by using call by reference, we save both computation and memory space because arguments do not need to be copied. But on the other hand, this harbors the disadvantage that variables can be accidentally changed in a function call. So special care has to be taken to protect the values that we don't want changed. So if we want to require arguments, we just define the parameters. Like here we have A and B. So if we try to run divide 9 by 3, we'll get 3. But if we try to divide 10, we're going to get an error. And it's going to say missing one required positional argument, B. So we didn't pass this. Now we can make some of the parameters defaulted, so they can have a default value. So now we can run divide 10, and it will divide by the default 2. So now we can run divide 10, we'll get 5. We can also have flexible length arguments with an asterisk, which will make n a tuple, so that we can pass any number of arguments to this, from 0 to many. And that's it, guys. That's a short one today. The assignment is to write a program that passes a list as an argument to a function and demonstrate that we can update it in the color scope. Alright, well, that is it, folks. You can have some private tutoring lessons if you want to do so. There are other by going into codingbootcamps.com. There are other classes, follow-up classes for this one. Learning Python by object-oriented programming examples. There's more software engineer training.
Thanks for watching. Please like and share this video.
At codingbootcamps.com for Java, C, C++, Go, Kotlin, and other languages. So that's it for the introduction, and you'll have to stay tuned for course projects and for the follow-up class. But for now, let's say goodbye, and thanks a lot, guys. Intro to the Python Programming Language. Projects Companion to the course that I ran for Coding Bootcamps. I want to check that out. codingbootcamps.com. My name is Stephen Elmaroff. This Projects Companion will talk about 4 different videos. This particular video will talk about the dice game that we're going to be writing in the Python programming language. So that is a guess the rolling dice game. It's going to be a 2-player game. Each round, both players guess the number on the rolling die, and the player that guesses correctly more times wins. That's basically it. Pretty simple. So let's get into a procedural way to write the code for this game. After that, we're going to look at a little object-oriented programming. But for now, let's just get the gist of it down with running just regular procedure calls, function. Okay, so the first thing we want to look at would be this hash bang here. This is a way for script files to tell an operating system what interpreter or what preprocessor to run. And we are going to call this program env, which is located in user bin, and we're going to pass it a argument called Python. So let's look at the terminal for a second. Now, if we get that again, we say user bin env. It's going to print out a bunch of this stuff. And if we say Python, it's going to print our Python interpreter, Python 3.6. That's what that does. Okay, so let's look at that again. Now we should be able to just run this program. If we're going to just execute the program, then let's say dot. It's going to the hash bang has to be the first line of the program, and it has to have this hash and then a bang, and then you can give it a command. So we tried to do that, but it said permission denied because we don't have any executable permissions on the end of our. If you don't know, this is Linux, the default way to list files, the long version. LL is short for ls minus L. And I'm running OpenSUSE leap for 15. So I can say I can add execute permissions to this program. And now you can see we have the X's on there. So this is the owner. The owner has read, write, execute permissions for this file. And the group, the owner is staff. And the group has read and execute. No write permission, just read and execute permissions for this file. The group is users. And finally, all the others also have read and execute permissions. So everybody that can access this file can execute it. So now we can run it. It says how many rounds you want to play. We'll play one round. A, guess a number 1. Got it. What a good guess. And B is also going to guess 1. Try to get... Nope. Dice rolled a 2. So A is the winner. 1-0. Okay, so that's the basic game. Now let's just look at the first line again. Let's take that line out. So let's take this line out. And now that line is gone. Now let's try to execute it, and it's going to do some other crazy thing for... I'm not exactly sure what what it tried to do there. Something interesting. You gotta be careful with running programs. So let's put that back. Let's go back to our Visual Code and put that back in. And it looks like we want to, let's instead look at this version. Alright, so you can see we have the hash bang is gone. Now let's put it back. And then try to run it. And see if we can now run it again. And now it runs. So, okay. So let's go through the code. We are importing a standard library module called random. So we can generate random dice rolls, or 2 dice, 1 die. So in this case it's 1 die, a random die roll. So let's... Well, we don't need to talk about importing. I talked about that in the students video. So let's just continue on with the code. We're going to define a helper function here called getInit, and we accept 3 arguments: a text, a minimum, and a maximum. So min and max are built-ins to the Python programming language. We can see that. If we go in here, we can type in min, and it's a built-in function. So we can say, what's the minimum of 1, 2, 3? Minimum. So let's... Well, the reason we're defining this is that we are going to ask for input from the user, and then we are going to check if that input is between the minimum and maximum that we want. So if, you'll see in a minute that we don't want somebody to, say, guessing the dice roll or the die roll. We don't want them to guess negative numbers or 0 or 7 or 99 or anything. It has to be between 1 and 6. So we'll see that as we can see down below the get int. We're going to be say, hey, this is our text. And we say, hey, guess a number between 1 and 6. So we'll see that in a second. Actually, we've already seen it, but we'll see it again more slowly this time. So that's our get int function. Just a simple helper. All right, so now this is where our program really begins. After our import and we declare the helper function, now this is where our real main line begins. At line 12, we're going to ask the number of rounds. So we say get int, which is the helper we just defined, just talked about. We're going to take the value and put it into, via this assignment operator, we're going to store it into this new variable we're declaring called rounds. Python's great. You don't have to declare a variable. Just use it. Just assign to it. If it exists, it'll overwrite it. If it doesn't exist, it'll create it. Pretty simple. So we're going to give it the text to say, hey, how many rounds do you want to play? And we're going to limit them between 1 and 20. So we're going to set our initial counters to 0. And then this is where our game starts. So we're going to have a for loop here and say for however many rounds they declare, or they tell us it when we ask them to say how many rounds you want to play. They say they wanted to play 20 rounds. Then the range function will return an object that produces a sequence of integers between 1 and 20. All right, so we can say, so range 1, 20. Range 120. Say print. Yeah. Between well, you can give it a stop, but let's see, between 1 and 20, we can say, I think you have to list it out because it comes back as a range object. So it'll go up to 19, and if you just say range 20, it'll go 0 to 19. I think that's really what we want. So if somebody says they want 20 rounds, then it'll go between 0 and 19. That's 20 numbers. If you count 0. So we'll print that out, and then we'll say, okay, A, well, via this function, we'll say, A, guess a number between 1 and 6. And we're saying range. Oh, we're just getting the input here. So this is the guess here. We're going to say, so he guesses 1. And then we're going to say, now dice is capitalized. This is, I think this. Let's see. Should we do it? Should we change it? Let's do it, because usually we have variables with a lowercase name and objects, factories, classes, and such. Well, take uppercase. Okay, so we're doing the same thing for A and for B, and that is basically we're taking the guess, and then we're taking the dice roll, and we're saying if they're equal, then we got it, and we're increasing his.
Thanks for watching. Feel free to add your questions as comments down below.
His win counter. And the same with B. And then at the end, we're going to compare them. If they're equal, then it's a tie. Otherwise, we declare the winner. Pretty simple. So let's see it's running here. How many rounds? Let's play 3 rounds. All right. How many rounds? All right, round 1. Guess a number. I'll guess 1. Dice was 3. B, guess a number. 3. Got it. It rolled 2 3s in a row. Nice. Okay, round 2. A, guess a number. He's also sticking with 3. Boom. Dice rolled 3 3s in a row. That's almost raising red flags for a bug in the program. And I did change that dice variable from upper to lower. So let's stick with a winner. B, guess a number. Oh, it was a 4. Round 3. Guess a number. All right, now it can't be 3 or 4. So let's say 2. Boom. Score. This looks like I'm cheating somehow. And we're going to go random here. B's going off the board. 5. Now it was a 3. Should have gone with a 3. So A is the winner. It would be good to put the score here, you know, like how many for each player, since there were so many wins here. But that's the basic game. So now let us take a look at the object-oriented version of the same game. All right. So say play 2 rounds, and then he's going to guess a number. 1. We'll guess all 1s. No 1s were rolled. So this program works. Okay, so let's look at the code. We've already sort of peeking at it, but we've introduced, again, we've looked at this boilerplate from the last program, and now we're going to define a class. 2 classes, as a matter of fact. We're going to define a player, which has a constructor or initializer. I guess under new would be the constructor. You could think of it that way. And this is a dunder init, because we have a double underscore. And you can think of this as a constructor for whenever we create a new player, this is the code that gets executed. And bound methods are going to receive automatically from Python as the first argument a reference to itself, which is, you can call it anything you want, but everybody calls it self. You could call this variable anything you want, but it's just good to call it self. It's standard. So this will accept from the user code, 1 argument, name. So when you create a new player, you're going to give it the name, and which we don't create a player directly. We create guessers, because the guesser class inherits from player, and it has its own quote constructor, which it accepts the name, and then it calls the super, and the super is the call to all of the based on the method resolution order, all of the other classes that it inherits from. So it's going to call super here is going to call player.init and pass the parameter we were passed. And then it will finish off its construction code. Just initialize underscore guess to 0. So it has one function and one property. And this is a getter and this is a setter. This is Python's way to do it with these decorators. To me, this is kind of a funky way to do it. It's not very pretty as Python is. It just is a little clucky here, but if you read internal conversations, everybody's got their opinion what they wanted it to be. And Guido, the benevolent dictator for life of the Python programming language, or I should say the first benevolent dictator, he said, okay, let's do it like this. This is how you can say, whenever we reference guest, you can see guest here is a function. We're defining the function here called guest, and we're saying player.guest equals role. So, this doesn't have, we're not saying player run player.guest. Doesn't have parentheses. It's not a function. How come it's not a function? Well, that's because it has this decorator here, which we're not going to get into. But basically that turns this function into a property. So it does some internal renaming. But basically we also have this internal thing. So actually the value we store inside of the class is underscore guess. And this is not a very good example because it's usually underscore guessed. But suffice it to say it works. And then this is the setter. So whenever you query this guesser, instantiated guesser object, so it would be player or whatever dot guessed, and you want to know the value, or you're reading the value, you're running this function, and when you're setting the value, then you're running this function. It passes the value. So object-oriented programming basically lets you define these classes, and then you can call them. Here you can see they're called with a parentheses, and you pass it any values it needs. There's our name, and it will create an object from this guesser class. So now player A has this interface for this class. It has an init method, which you don't need to call manually, but it has a guess method and a guessed property. So let's run through the code here. Basically the same code we saw, but we have player A and player B, our guessers, and then we loop them. So once for player A and once for player B. We're creating a pointer to first player A, then next time we loop through player B. So we're saying player guess. Go ahead and guess, and it's going to say, okay, take the name, and it's going to say name, comma, guess a number. So name, comma, which should be player, first time through it's player A, so the name for player A is A. So we're going to say player A, guess. And then he'll input it and guess. And then we'll say, okay, and then we'll get a roll, and then we'll print what it was rolled, and then we'll compare them. Are they equal? And if they're equal, then we got it, and we increase our wins. Same as the last program. And that is basically it. So we have this guessed business here. And we're going to say, let's get rid of this guessed here. This is just a little bit unneeded functionality. Just making it overly complicated. And let's say guessed. So we'll start off guessed as let's start off as none, and which is a Python object, and we will say when you guess, it'll save the guess inside of there. So let's see if it still runs. Let's try it. How many rounds? Let's play one round. Player A guess a number. A guesses 1. 6. B guesses 2. Well, it was a 3. It's a tie. So you can see it worked. And this is much easier for those who didn't really follow my bad explanation for the getter and setter property decorators. Then this is really all that's happening. We have this guessed variable, but we didn't change how we used it. It's still used down here as guessed. And that's basically it. So I hope you learned something. And be sure to check out the other videos if you want to see some more project programming. And we will see you in the next video. Okay, thanks guys. Hello, and welcome to Coding Bootcamp's Intro to the Python Programming Language Projects Companion. To the course that I ran for Coding Bootcamps, you might want to check that out, codingbootcamps.com. This project's companion will be 4 different videos. 4 different games written in the Python programming language, and this video will look at the simple one called reverse. So let's have a look at that. We're going to write a program using a function that asks the user for a long string containing multiple words and print back to the user the same string except with the words in backwards order. For example, if I say my name is Legend, I would see the string back to me. Legend is name my. So let's get to the code and start coding. Alright, here is a 9-line program including comments. This would probably be for SLOC, source lines of code. So we can see the comment in green begin with a hash, or also known as an octothorpe, also known as a pound sign or the number sign. That's how you begin a comment. Comments in Python are just one line. They are not multi-line comments like Java has. Python just has single line comments. So our comment says we wanted to define a function to reverse the input. Okay, fine. So here we define a function, and we use the def keyword for define. So we give it the name of the function, reverse input. And then in parentheses, we'll give it the list of parameters. It only has one required parameter, words. You can call it anything you want, but this is a good descriptive name for what it's going to get. So then you have a colon and then a new line. And in Python, as we saw in the class, indentation is very important. So I'm going to assume that you went through that class already, so you know a little bit about Python. So here in the return statement, we're sending back to the caller a string. And now it's a little bit funky in Python the way they're going to take this string, but actually the string is words. Remember, it's a string of words, and words are characters separated by spaces. So in most programming languages, you work inside out. So we have our words that are given to us in the function, And we take that argument and we run reversed on it. So we run the function reversed. And we can see, you know, that'll take an object of a type sequence and it will reverse.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Reverse the iterator over values of the sequence and return a reversed iterator, which will iterate over the words given to it in reverse order. Fine. Okay, so now we have that iterator, or which is, and we turn it into a list. And then we join that list with spaces. It's a little bit funky how that works, but that's how that works, inside out. So we're done defining a function. Nothing gets run here. So our main line of the program starts here with a comment, another comment. Our main line starts here with words. So we're defining a variable called words, and we are going to set that equal. This is the assignment operator. So whatever's on the right hand gets assigned to whatever is on the left hand. So we're going to run the input command, and this is going to run the command line. All this is command line stuff. So we're going to give it a string. Input takes input from the command line, and it will output it into whatever you want to put it in. So you will give it this long string here, and after input accepts the string, we're going to split it into an array, or what Python calls a list, and it will, by default, since we don't give it any arguments here, it'll split it on the spaces. So the next thing we're going to do is we're going to print out, remember this is Python 3, so we're going to print is now a function, so we have to use parentheses. So we're going to print our words in reverse order. So we're going to take our words and we're going to give it to this function we defined, and which will be returned to us the words reversed, turned into a list, and then joined together. That's what gets returned to us when we call our function. So let's run it, and so let's see what happens. So what Python we got? So we're running Python 3.6, and that is going to be the minimum for this project's companion. So we can get into the interpreter here. So now we can issue commands, and I think we can exit with exit or Control D. So let's run our program, which is called reverse. So let's run it, and we can see, might even be better to run it inside of the terminal here, so we can sort of see what's going on. And I'm just learning Visual Code here, moving from Sublime Text, just learning a new editor here. Visual Code seems really great. So how do we just run the program here? Run file in terminal. It looks like it. Okay, so please input a long string containing multiple words. You guys see that menu? No, you can't see that menu. Alright, so please input a long string of multiple words. What if I gave it the long string of multiple words? It would return words multiple containing string long A input please. So if I give it nothing, nothing. If I say yes, it say I am legend. Legend am I. Pretty simple program. And let's just leave it there. So there's 3 other projects in this companion, like we said. And be sure to check those videos out too. They're going to be more detailed than this one. We have dice game, hangman game, and we will print student information. Okay guys, that's it for this one. We will see you in the next video. Thanks. Hello, and welcome to Coding Bootcamp's Intro to the Python Programming Language Projects Companion to the course that I ran for Coding Bootcamps. You might want to check that out, codingbootcamps.com. This project's companion will be 4 different videos, 4 different games in the Python programming language. And this video we will look at Hangman. So let's have a look at that. We are going to write the classic, popular Hangman game, in which one player thinks of a word or phrase or a sentence and the other tries to guess it by suggesting letters within a certain number of guesses. In this project, it will limit it to a single word. Make it easy. The program starts by asking player A for a word, then they enter the word, and then player A enters the word, which will be displayed on the screen with underscores instead of letters. The number of underscores are the number of characters. Now, basically the rest of the game is player B's turn, and they're going to guess the letters one at a time, and if you guess the right letter, it throws it in there. If you guess I and the word is inception, it'll put the letters in the right spots, and then you can guess again. You can only get 3 wrong guesses though, and you have to guess it without missing 3 letters. And if you never played it before, that's pretty much the rules to it. So you'll see as we get going. So without further ado, let us get into it. Okay, so here's our code, hangman.py. And the first thing we do is we run an import statement. So we are going to throw this word into the global namespace, getPass, and it's coming from a module called getPass. So getPass, the module, it is a utilities module. So let me back up a second. So in order to get somebody else's code into your program, you can import that library. You can import that code. If it's packaged up properly, you can import it into your program. So getPass is not in this program, and it's not built into the Python programming language itself, but it is included in the standard library. So, for example, we don't have to import. You can see this, we're using this keyword while, or this object type set, or this function len. And we're not importing those. Those are built into the language. But getPass is not built in, although it is included with Python. So we don't have to install any software on our system once we have Python. We can just import it, because the standard library comes with every installation of Python. So the module getPass is utilities to get a password, and we're going to prompt, it's like input that we saw if you did the reverse project, where we reversed some words. We ran an input command that allowed you to input something on the command line. So this will do the same thing, but for a password, so that we're not going to display the password. We're not going to, when we ask the player A for the word, we don't want to display it so that player B can't see it. We'll just assume he doesn't watch player A use the keyboard. So that's all it does. It blocks out whatever you type in. So it's useful for inputting passwords, and we're going to use that here because it's also useful for us to hide the word from player B. Okay, so after we have getPass imported, we can use it. And we're just going to print a comment here. You know, comments begin with a hashtag. So we're going to define a variable called word, and we're going to put into that variable the results from getPass. Now when we run getPass, afterwards you can see we're going to strip off any spaces on either end of it, and we're going to put the word into uppercase. So the argument that we send to getPass is the prompt string that we want to display to the user. So we're going to display to the user, hey, player A, enter the word. Then a colon, then a space. And whatever we get back from getPass, we're going to save in our word variable. Okay, after we have our word, we're going to set our cars, our characters, that's maybe shorthand for characters. We're going to set that to be an array of, now this is a list in Python. It's called a list in Python. So we're going to create a list of characters, of the underscore character, one for each letter in our word. So we're going to take the length of our word, say our word is hello, then we're going to take the number 5. The length of word is hello is 5, H-E-L-L-O, and we're going to multiply that, so 5 times an underscore, so we're going to have 5 underscores, but that's going to be a list of 5 underscores. So once we have that cars variable, we're going to set our guest, create a new variable called guest, and set that to an empty set. So we can run let's run, let me just hop over quickly to another program, and I'm used to using Sublime Text, but I'm now using Visual Code because it seems great. So we can import this library PDB, which is the Python debugger, and we can stop the interpreter wherever we want and inspect anything inside of there, like variables and whatever, memory addresses. So let's do that so we can see what these variables are. And, just take a look and see what we got. All right?
Thanks for watching. Please like and share this video.
Run Python. Okay. So we want to, can we run it here? So now we are inside of the debugger. You can see we have this little prompt here and a little debugger prompt, so we can we should be able to list. No? Doesn't seem to be working necessarily so great. So player A, enter the word. So I was inside. No. Okay. Player A, enter the word. And so let's say the word is hello. See, I typed it, but you didn't see it. Huh. So now it's telling us the next line it's going to run is incorrect, which you can see is line 10. But you can see the arrow is pointing to, line 10. That's the next one it's going to run. So we've already executed lines 1, 4, 5, 6. So let's see what the value of word is. Word is hello. I typed it in lowercase, but it uppercased it, remember? We did that in line 4. And let's see what the value of cars is. Yep, 5 underscores. And let's see what the value of guest is. It is an empty set. So that's pretty much all we've done so far. Let's quit. And let's get back to it. So now we can continue with our line number 9. We're going to set a comment here, and we'll say we want to set the loop for at most 3 wrong guesses. So we say incorrect is 3, and we'll decrement it every time we get a wrong answer. And then what we're going to do is we're going to enter into a while loop. And the while loop is fairly long. It goes down to here. So it goes down to line 41. So we're going to enter the while loop. We're going to say while incorrect. So this is while this expression, while is a loop keyword, and we're going to loop now as long as this variable is evaluates to true or truthy. So 3 is truthy, 0 is falsy. True is true, and 3 will Python will just assume you mean true when an evaluation comes to something other than 0 or false or empty set or something empty like an empty list. Also, anything that it has any kind of value, it'll assume it. It'll think you're trying to say true. So we can say we want to loop while we have more than 0 incorrect guesses left. So the first thing we're going to do inside of our loop is we're going to print our characters joined up as a string. So in the very first time, remember we printed our cars was right. It was all underscores. So it's going to join them back together. and it'll be just a nice string, so that'll be the thing we need to guess. All right? So then the first, we're going to create a variable inside our while loop. We're going to input the word, the guess, actually the character from player B. So we're going to tell him to enter a character. And we're going to say it's if they give us more than one character, we're just going to take the first one. And we're going to also uppercase that, so we can compare them, upper to upper, apples to apples. So whatever the player B inputs, we're going to save in the variable guess. This is also how you declare a variable. Just assign to it. Again, the equal sign is the assignment operator. Right goes into left. Okay, so then we are going to find the character in the variable. So if they did guess something, then we're going to get into this loop now, into this if statement. Now you can see down here that else, if they didn't guess anything, we're going to break out. But if they did guess something, then we are going to say, we're going to check if guess is in our set of guessed letters. So remember, we had guessed was an empty set. We printed guessed out as an empty set. If there was anything in there, it would have listed it for us. So if they guess the first letter is A, they're going to say if A is an empty set, no, that's going to be false. Because the first time around, they didn't guess anything. So this if statement here is just, we don't want to penalize them if they guess X and X is not in there, and then they guess X the next time. We don't want to penalize them for the incorrect guess because they already guessed it. We'll give them a break. So the first time we're coming through, when they guess something, we're gonna add it. So next time it comes through, we'll check it. So here's the bread and the butter down here. If the guess is in the word, so if whatever they guessed is in our actual original word, right? And our word was hello, which we uppercased. So if they guessed the letter A was in hello, no, it's not. So we're going to go down to else. We're going to say incorrect, decrement incorrect is -1. Whatever, it's going to be 3. Now it's going to be 2. And we're going to print out some messages and see how many they have left, and then we're going to go back up to the loop again. But if the guess is in the word, so if they guessed the letter H, and H is in hello, then we're going to say, yes, you guessed it right. And then we're going to loop through all of the letters in word. So here's a complicated looking statement here. It's a for loop, and inside the for loop we only have one statement to execute, which is we're going to take our cars, and remember cars is those 5 underscores. We're going to see how those are used in a minute. So we're going to take those 5 underscores and we're going to replace them with the actual letter. So let's see that. So the loop, so this is called a comprehension. In this case, we can see it's a list. It's surrounded by square brackets on either side, so it's a list comprehension. And the list comprehension is going to be looping on. The list comprehension is going to create a list. And the list is going to be, in our case, it's going to loop through, using this keyword, it's going to loop through all of the words, or all of the things inside word. So that's all the letters inside our word, right? And our word is hello. So it's going to loop through H-E-L-L-O. It's going to enumerate those. And enumerate's going to take an interval, and it's going to return an enumerate object, and it's going to also give back an index. So you can see at the bottom there it says 0 in sequence 0, 1 in sequence 1, 2. So it's we're going to get back from that 0H, 1E, 2L, 3L, 4O. Because what we want that index for, so that's what we get back from enumerate is going to be into this tuple. It's going to be the index 0, 1, 2, 3, 4, and the characters HELLO. So like I said, 0 H, 1 E. Sometimes when things get too confusing, we say, okay, let's go into our Python debugger and debug it. All right, so we're going to add this in there, and we're going to debug it. All right, so let's put that at the bottom. Let's say print dummy, because otherwise it'll go back up to the 4 and it'll be confusing. Just a little bit from experience. There we go. Okay, so let's try it again. Enter the word HELLO. I think I typed that right. So there you can see the underscores. Oh, in this terminal, it's not quite clear that there are 4 separate underscores, or 5. So anyway, looks different on my other terminal. So okay, player B, enter a character. I'm gonna make a guess. I'm gonna make a guess. X. And it says nope, just like we said. So we didn't enter our debugger because we didn't enter we didn't enter something that's in the word. So let's do that. That was being kind of funky. So all right. So we enter H and we say yes, H is in the word, right? So let's we are here. We say yes, H is in the word. And now we are at line 31. All right? So now we're like down here, like we said on the dummy. All right? So now we can view everything that we have in our local stack there, which is in our for loop. So we can say print C. Okay, so C is 0. Because H is the 0th index. So let's have a look at this comprehension and let's see what we get. Now notice at the end of the comprehension, we're only taking, we're going to get the index of everything, but we only want the ones where car is equal to the guess. All right, so this is kind of confusing. That's why we're going to be inside the debugger here. So let's print this. Let's print this out and see what happens. All right. So car is. Oh, car is. No, we don't have. Car is only available inside the comprehension. So guess is H. If our guess was where a character equals, and instead of our guess, we could also rerun the debugger. But let's say if our guess was L, we'll get back 2 and 3. Because that would be 2 and 3. Okay, so that makes sense. We quit out of there. So now we have now we are running. Remember, we're inside of our for loop here, inside of our while loop. So we say characters sub C. So remember, C is, so we're looping through all the correct characters. So for L, it was 2 and 3. But for our guess, H, it was 0. So each time it goes, each correct letter, it says cars, which was our underscores, right? Cars was our underscores. So cars sub 0 is H. Okay. So now cars should be H underscore 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 underscore.
Thanks for watching. Feel free to add your questions as comments down below.
Alright, so now once they made a correct guess, we are going to check if it's correct. So we're going to say when we join cars back together, if that's equal to our original word. And at this point it's H underscore 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 underscore. Does that equal hello? No. So we're not going to break. We're going to keep going down, and we're going to skip down past the else. We're going to get to pass this up because we did guess something. We're going to exit out of our while loop. And we're going to, well, no, we're going to just loop back up to our while loop. We'll get to the end of the while loop, and we're going to loop back up. So now we're going to say incorrect. Everything's right. Let's say we just, incorrect is still 3. So we're going to go back and do it again. And that's the whole program. So when we say player B enter a character, but leave it blank to guess the word. So you can also guess the word before, so you don't have to guess all the letters. You already know the word. You can just guess it. So we tell them to leave it blank. So if guess, we do all of our code. But otherwise, we're going to input, hey, what do you think the word is? And we're going to save that into cars. So when we're all done with our loop, we are going to see if our cars, if we have success. So we're going to join our cars back together, and we're going to see if it's equal to the word. So basically, if cars equals the word, then we say success. Otherwise, failure. Otherwise, just failure. All right, so let's see it in action, shall we? All right, so let's run it. Yeah, let's just type it in instead of hitting stuff. Player A, enter the word. I'm going to type in hello. Player B, enter a character. Let's guess H. Yes. Oh, we didn't. We got to save our program here. This has changed. Reload. We have to save our file here. Forgot to save it. So let's run it again. Player enter the word hello. Player B enter a character. I'll guess H. Yes. So we can see that there's our underscores. You see on this terminal you can see the underscores a little better. Now there's an H there, so that was cars sub 0. And now I'm going to guess L. Let's see what happens. Yes, L is in the word. And now I'm going to guess X. Nope, X is not in the word. You have 2 more attempts. E. Hell. Well, we don't even know what the word is because maybe it's hello. I think I typed in too many letters. So let's see. I'm going to guess O. Yep. Oh, but there's something else there. Now it's actually kind of fun. What did I type? Maybe what's next? Maybe a P I typed because it's next to O. Yes. I guessed my own word right. I should print the word there, actually. This program should print the word. Yes, P is in the word. And I'll say success. And we should print that word. So let's do that. Let's print the word. All right, so at the end we'll say print the word is, and then we'll say word. So now we'll say, all right, word is word. So now let's run it again. And the word is going to be hello. And I'll guess X. Nope. H-E-L-O. Success. The word is hello. Okay, guys. That's it for Hangman. Don't forget to come back and see the other games we have. And that'll do it for now. So we'll catch you guys in the next video. Thanks. Hello, and welcome to Coding Bootcamp's Intro to the Python Programming Language, Project's Companion to the course that I ran for Coding Bootcamps. Might want to check that out, codingbootcamps.com. This Project's Companion will talk about 4 different videos. The one we're going to be working on today will be students. So be sure to check out the other ones. But for now, let's talk about students. All right, so let's look at the code. Well, first let's talk about what we want to do. All right, so we've got a CSV file that contains information about students in elementary and middle school. It looks something like this. And we've got their age and their hobby and their grade and their school. And so we want to load the file, and we want to perform 7 different tasks for this data. So first we want to find the students that have the same hobby, because each one has a hobby. We want to find all the students named Jack. We're going to randomly add, well, the gender is now in the file, so we're randomly going to add enrollment. For each student. So whether they're enrolled or not. And then we're going to flip it. So if they were enrolled, then they're going to be not enrolled. And vice versa. Then we're going to calculate the average invariance for each student. For each school, actually. And the average invariance for each sex. So average invariance for males, and then average invariance for the females. And finally, we're going to find all the boys who love fishing. Okay, so with that in mind, let's get into the code. Now the code is, this program is like 122 lines. And it's broken up into all the sections. So what we want to do is, during our code here, we're going to use these 4 different libraries. And all 4 of these are included in the standard library. And that means that they're not included in the Python executable, but they are included in the Python executable via the bootloading of the environment we're running, like the interpreter, for example. It will automatically load it will load the standard library. But if you see this keyword tuple, we don't have to import tuple. It's automatically included because it's a built-in. CSV is included with the distribution of Python, but the standard library packages have to be imported manually. We could also install packages like numpy or something like that, and then we could also import that. But these packages don't have to be installed because they're included in the standard library. They just have to be simply imported. So we have a CSV module, which reads and writes CSV files. We got a random generator, so it can generate random things for us. We have statistics, which we're going to use the default dictionary. Well, that's in the collections actually, and you can see there's a counter in there, order dict, although in Python 3.7 order dict is now a language requirement. So now let's get to the code. Alright, so first thing we're going to do is we're going to create this dd variable, which is actually going to be a shortcut for our default dict class. So we can create a default dictionary, which is and then we give it the factory. So whenever we reference something inside the dictionary, it will automatically be, if it's not defined, whatever it is as we supply as the factory. So for example, a list, we can just use the list without ever declaring it as a one of the elements inside the dictionary. We'll see this as we go. So that's dd. Now let's read the student's data. That's the first thing we're going to do, read the student's data. And we're going to use our CSV module, and we're going to use the dict reader. So what it's going to do is it's going to pull out all of the data in our CSV. It's going to pull out, so for the first one, it's going to get all of the, it's going to use this as by default as the field names, and then it's going to say, okay, for the first one, we're going to say name equals William, school equals high, age equals 17, hobby equals soccer, grade, he gets a B, and he is a boy. So once we open our file, we're going to pass it to the dict reader, and then at the end we're going to create a tuple of all of the dictionaries, which will be like a little mini database. So the first element in the tuple will be the first row of our database, and then all of the fields inside will be the columns. So you know, tuple is just like a list, but it's quote quote immutable. All right, so with that in mind, the students now contains the data. We're going to look at this briefly here, just show you exactly what's in here. But I'm going to run through the code quickly, and then we're going to see it in action. So we have some print statements here, and we're going to set hobbies equals, this is a dictionary. Actually, this is a set comprehension. So sets also use curly braces, just like dictionaries, but without the key value, just the key, as it were, or actually just the value. So it's going to be a set, which is non-repetitive list of hobbies, students' hobbies. So the comprehension uses a loop, and it will loop through all of the students, creating a temporary variable called student, which we want to pull out the hobby. So for all the students, we want to create a set of all of the student hobbies. So this hobbies will be, for example, soccer, hiking, fishing. Get the idea. We'll see that in a second. We're going to print something else out, and then we're going to enter a loop. We're going to loop through all of the hobbies, and we're going to print out the hobby, and we're going to title it, so that it's just title case. First letter is capitalized. So we're going to print out the hobby and then a dash. And then we're going to print out, we have another comprehension here. Now this time it's a list comprehension.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Comprehension, because it has square brackets. So the loop is going to loop through all the students, creating a temporary variable called student. Going to loop through all the students, and if the hobby is equal to the current hobby that we're looping through on the main loop, this is a for, not an or. So we're looping through all the students, and if the hobby is equal to our current hobby, then we are going to print the name. All right, so that's this print statement here. And then we are done with our first task, our first problem, as it were. Problem solved. All right, so we're going to get on to the second one. And the second one is going to find the students whose name is Jack and output his data. So we're going to loop through all the students, and if name is Jack, then we're going to print the data. Print that student object. We could also use a filter to filter down using a lambda function. And then we have to use this tuple to print the filter results, because it's a filter object, so we have to pull it out into an iterable, a viewable iterable. But this is not as pretty. This is not as readable as, because code is read far more than it's written, far more often than it's written. You write it once and read it many times. So this is way more beautiful. So that is number 2. Number 3, we need to add enrollment. So whether the student's enrolled or not. So we're just going to loop through all the students, and we're going to say the enrollment, we're going to create a new entry here in the dictionary. Our dictionary, we're going to see all this, don't worry, we're going to see exactly what all this looks like. So in this dictionary, the database row, as it were, we're going to, if enroll doesn't exist, we're going to create it and set the value to a random choice. So we're going to say, we're going to pick randomly from true and false. And we're going to say, oh, is he enrolled or not? And then we're going to print it off. So we're going to print the student name, and then, comma, we're going to print is enrolled if the student enrollment is true, or else it's going to print nothing. So we're going to say William is enrolled or nothing. All right, so that's number 3. Now, number 4, we're going to reverse the enrollment. So for all the students, we're going to say, we're going to reverse it right here. So student sub-enrollment is equal to not student sub-enrollment. So if this is true, then now it's going to be false. So now we are going to print off the student name and was enrolled. If it was enrolled, then we're going to say now he's not enrolled if he was enrolled. That's the basic idea. So number 5, moving on to number 5, a little bit bigger, number 5. So we are going to print the average and the variance of each school. So we're going to write a helper function here called getScore, which basically just says if it's an A, we're going to assign that an integer value so we can work with numbers. So B is a 3.5 and C is a 3. And anything else is a 2. But I think our data only has A, B's, and C's. So that's a helper function. Let's just remember that's there. So now we are going to create a new variable called school scores, and that is our, remember, our default dictionary. And we're going to pass it the list constructor as a factory function. So whenever we access something inside of DD, we're going to get a list. So we're going to loop through all the students again, and we're going to say the school scores sub, well, maybe this was high school, so it'd be high, or elementary, or middle school. We're going to add into our list. See, we're not creating this. Nowhere do we say, okay, normally we would have to, if we didn't have a default dict, if this was just a regular dict, we would say, like an empty dict, we would say school scores sub school equals, now this is an empty list. But we don't have to do this if we make a default dict. So it's just a little easier, a little cleaner if you know what this thing is. So we're going to append to this list, and the default dict, remember, like we just said, it's going to create the list if we don't have it already, which the first time through we will not. So it's going to create this list and append to this empty list the get scores of the student. So if the student has a B, he's going to get a 3.5. That'll be the first element in the list. All right. So then we're going to loop through all those scores, and we are going to print off the school, so high school, and we're going to print off the list that we just accumulated. Now we could do this in a fancy little list comprehension, but it's way easier to read this. Way easier to understand that. So then we are going to loop through all of the school scores again, and we're going to print off the data. So first here we're just listing them. We're not trying to break any land speed records with fancy, reading this only once. We can read as many times as we want. It's not going to take milliseconds. So we're just going to print off all the schools in the list so we can see them. We don't really need this for our project, but it helps to see the data. So this is what we want to have in our project here. We want to loop through the school scores again, and we're going to print out the items. We're going to loop through the items, which is going to give us the key and the value. That's what items does. So we're going to loop through the scores, and we're going to create total and account and average and variance, and then we're going to print them off. Now we could talk for a minute about this fancy thing in Python 3.6 what we got, which I waited for a long time, because otherwise you would have had to done some other more funkier kind of formatting here. So if we precede this a string literal with the letter F for format, then inside we can use the curly braces as a variable separator. A variable would be like a declaration of a variable, and we can, well, the use of the variable. So we're going to print off here the school variable, and we are going to have, and we say colon, and we're going to say it takes 13 spaces. So we're going to pad it with 13 spaces, with how many spaces it needs to be 13 characters wide. So that we're doing this in a loop, so each of our lines we print out are going to align vertically. And the same thing with count. It's going to be right aligned. Left aligned is the default for strings, but at a number we can right align. That's what this greater than is. So we're going to have the count be right aligned 4 spaces. Total aligned will be right aligned 7 spaces, and with a 1 digit after the decimal point. Average will be right aligned 8 spaces with 2 places after the decimal point, and variance will be right aligned 9 spaces with 3 places after the decimal point. All right, so that's number 5. Now moving on to number 6. we want to calculate the average of grades by sex, so male and female. So, like we had school scores as a default dictionary. Now we got sex scores, so males and females. We're doing the same basic thing we did before, but we're going on the sex of the student, and we are going to say sex takes 2 places, so it's M or F, and then we're going to put the scores. Pretty simple. That's the same thing we did before, just to give us our data, and we're going to do the same thing with printing off the variance and average and total and count. Alright, so the last thing we're going to do is going to print boys who love fishing. So we're going to loop through the students, and we're going to say if it's a male and he likes fishing, then we're going to print his name. Pretty simple. Now, let's see this baby in action. Alright, so let's say we want to run Python student.py. Alright, now let's go over our terminal and do it, because we're going to need some more space here. Alright. Alright, there it just went by. Did you see it? Alright, so it's going to be hard to read, but we just want to just get a brief look at it. How big do we need it here? Is that good? Alright, so let's look at the data. Alright, so we're running our program here. Python, we're going to run the program. And problem 1, same hobby. And actually, just for this, I hate to keep flipping back for you. Sorry about that here. Maybe it's a little bit easier to see as we're running through. Printing same hobby. Right, so print same hobby. And then we say hobbies. And then we print off the hobbies in our loop here. So that's the hobby title. Hobby, and when we title, we capitalize the title, capitalize the first letter, and then our list comprehension to print off all the list of all the hobbies. So there's our list comprehension, printing off all the hobbies for all the students that have that particular hobby, if hobby equals hobby. So number 2, find all the Jacks. Right? If the name is Jack, we just print the data. That one's pretty simple. And there's this one guy, that's his data. This is the next guy, another Jack. So there's one Jack in each school, one in high school, one in middle school, one in elementary school. Number 3, we're going to assign a random enrollment. So we print off student name, and then if he's enrolled, we say is enrolled. So William, nothing. Susan, nothing. Sarah is enrolled. Robert, nope. Jack is enrolled. Patricia's enrolled. Michael, nope. Mary's enrolled. Linda's enrolled. Karen, nope. That's basically it. Number 4, we're going to reverse it. Remember, so enrollment equals not enrollment. That's the simple data there. Then we print it off. So William was not enrolled, now is enrolled. Susan was not enrolled, now is enrolled. Sarah was enrolled, now is not enrolled. So that's all the way through the list there. Number 5, the average and variance. All right, here is our average and variance. So we have our helper function here, create our school scores, and then we print them out, which is right there. So we print off scores, the word scores, and then we print, see.
Thanks for watching. Please like and share this video.
We're right aligned 11 spaces. So this is right aligned 11 spaces there. Same with them all. They're all right aligned 11 spaces. So then we print the list, which our DD created. And there's the list for all the scores. So now when we go to print off our data, we have the scores there for us to be able to see. And we have 5 students in high school, is that right? 1, 2, 3, 4, 5. We have 5 students in high school, 7 students in middle school, and 8 students in elementary. There's their totals, the average scores, and it looks like the young kids are doing pretty good, and high school kids are doing good. Everybody's doing pretty well in school, just by the grades. It's easy to tell by grades, but grades don't really give you the full value of the student, do they? So finally, we print the variance. Okay, and number 6, we do the same thing with the sex of the child. So male and female. There's a list of all the males. There's a list of all the females. And there are our numbers. And finally, a list of the boys who like fishing. That's the list of boys who have fishing as their hobby. Now, let us go back to our terminal. And first, boy, I'm really switching around here, aren't I? Let's start off by going into our debugger here. All right? And we'll see if that works. So now we will run the program again, but this time we entered our debugger at line number 11. All right, which is, now we enter it here, and our debugger should tell us that we are going to pause on line number 11. All right, so we run it. We are on line number 11. And at the students line, so we can list that. We can say, we're currently about to execute line number 11, but we stopped after line number 6. And let's print off DD. What's that look like? It's an empty default dictionary. All right. So we have our imports here. We can figure out where we imported things from. Right? We can say CSV. We can figure out where random is from. We can figure out where, and so on. All right. So now we're going to be at line 11. We're going to be executing the students. So let's say next, and now we can print students. So students is a tuple, and we can say students. We'll say type of students is a tuple. So we'll say print off students sub 0, and that is our order dictionary. But now in the new Python, actually I think it was Python 3.5, dictionaries became ordered by default, but that was a C specific implementation. So now it's language specific in 3.7. So if we can, it's easier to look at our dict here if we make it a dict. So the first student, right, we print student number 0 at index 0. We say his name is William, his school is high, his age 17, his hobby is soccer, his grade is B, and his sex is M. He's a boy. Okay, so now let's look where we are. We just executed line number 11. Now we're going to execute line number 14. So let's go down to, let's do that. We print that off. Print a blank line. You can see it there. Now we're setting hobbies. So there's our hobbies. And now for hobby in hobbies, we're going to sort the hobbies actually, and then we're going to loop through them, and we're going to print them off. Where are we now? So we printed them off. Right here. So we printed the hobby, and there's all the guys that have baseball as the hobby. Jack, David, and Charles. So that is our hobby title, and then our dash, and then our list comprehension prints off the list of those guys. So now we're going to loop through we did that one. So let's see, we're on line number 23. All right, so we're going to the next hobby. So now we have a new hobby. So the first one was baseball. So now we're on fishing. And now we can set a breakpoint. Let's see here. We set, we'll go to, so we'll set a breakpoint for 30. And now we'll continue. Now we're at line 30. So we don't have to go through the loop. Sit there, all the hobbies. Oh, there was only 3. So there, the rest of the hobbies are printed out. We already printed baseball, but now it'll print the other 3, fishing, hiking, and soccer. And now we are at our breakpoint at line 2, at line 30. And let's go into our loop for student and students. Now we're inside the loop, and let's print off student. William again, he's the top of the list. So now we're looking for all the Jacks. So we could, pretty simple, you know, if it's Jack, we're going to print his name. So we could also get this filter. Now, as you can see, it's a filter object, right? So Jax equals the filter object. So we could say print a tuple, or it could be a list of this lambda function. That's a function inside of an expression. So student, because we already have student defined, so we're going to give that to our lambda function, and the lambda is going to say, well, if the student, and we could call this anything we want, because now we're in the function. This is our function parameter we're going to call s, and we're going to say if the student name is Jack, then we're going to include it, or else if it's not, we're going to filter it out. And we're going to pass that lambda all of the elements one at a time from students. Unexpected end of file. Because that was our list. So there's the end of our filter. Actually, this is the end of our list. Oh. Function object is not lit, so we're going to take a list of let's just take the lambda function for now. So we're getting our lambda function and our students. So we forgot to filter them. So we were going to filter our students, and we get back a filter object. I'm going to try to save us some memory if we don't need them all, but we do. So now they're filtered, and so we can say, instead of print, we can say pretty print, the dict of that, of the list, pretty print. We could just pretty print the list. So we're going to see that the first Jack is, there's 3 Jacks here, so got Jack in high school, Jack in middle school, Jack in middle school, and Jack in elementary. But we're basically doing this by hand, but this is so much prettier for reading the code. The data should be the same at the end. Alright, so now we are, let's print a break. Let's have a new breakpoint to get out of this loop. We don't want to have to go through all those things one at a time. Let's break out and go to problem number 3. And that's line 41. And we'll continue until 41. And now we are print problem 3. Okay, so next. There, it printed it for us. And it's going to print again. And let's go into our students again. For now, we're going to assign enrollment. So let's go down into our loop there. Okay, so now we are inside of our loop. Student, that's what of course William is top of the list. And if we look, can we say pp dict, because pp of student, oh, pretty print is getting smarter all the time. Okay, so we have no enrollment in there. So now we're at line 45 and we're going to set the enrollment. Or if it was already something else, we are now going to set it to the random choice of true or false. So let's execute that. So we did that. Now let's do our pretty print for our student. And now we can see it tacked on enrollment on the end. And since it's an ordered dict, which all dicts are now, you can see it added to the end. All right, so it's going to do that for, no, let's see. So now William is enrolled. So go get another student and pretty print Susan. Oh, she's not enrolled. So it's just randomly enrolling them. So now let's break out to 50. And so there's a list of all enrolls, not enrolls. And we are going to reverse it now. So if they were enrolled, they're not enrolled. So let's go into our loop. Now reprint student, and of course it's William again, who is enrolled. And Hope you're following along here. This arrow here, you know, it points at the line we're at. Is everybody following that? Maybe you can rewatch the whole thing I've done here in the debugger with knowing that. Should have mentioned that in the beginning. So we're at line number 54. So we already have student now.
Thanks for watching. Feel free to add your questions as comments down below.
Already executed this line 53. So we can pretty print student, which we just did above. So that's William. And now, so student enroll is true. So now it's going to be not enrolled. So if we print off student enroll, it'll be true. Now, if we're going to execute line 54, boom. Now let's print it off, and now it's false. All right. So now it's going to print it off, and you can see how the rest of that works there. So let's continue with line number 66. So there's everybody enrolled, not enrolled, enrolled, not enrolled, enrolled. Christopher was not enrolled, now is enrolled. Charles was not enrolled, now is enrolled. And so on. Right, so we are at line 66, and we're going to, we have a our get score helper, and for students, school scores. We want to get school scores. Right, so let's go down to line 77. And let's say we're going to execute that. So now we're at, let's go to the next line. So now we are at line 79. So student, let's say school, is high. All right, so we're going, of course, we're at William again. And now let's print our student scores. So this student has a score of 3.5 because he's got a grade of B, and our helper function says it's 3.5. So now we are going to loop. Let's go back to the top of our loop. So we executed line number 79. Now we're looping back up to line number 77. So that means we should now have something in school scores. Right? And, well, there's multiple schools. So now it is a dictionary, really. So it's really just a dictionary, but it's this default dictionary, which has the list factory. So we have now one, for high school, we have one entry. That's William's B grade as a 3.5. All right, so let's go through all those, and we'll break at 81, continue there, and we'll print those. I think, how do you clear here? How do you clear a breakpoint? Break 77, does that clear it? How do you clear? Maybe clear 77? And not sure how to clear. Was that a clear? 77 out of range. Disable. I don't want to have to go through all those. No. Disables a breakpoint. So disable 77. Out of range. Oh, breakpoint 7. It told me that it's got a number. Why can't it just be the line number? So now we should be at breakpoint 7. Disabled breakpoint 7. at line 77. Disable 6. Disable 5. And how do you list all our breakpoints? We can say list no, disable. Nice commands. There's other debuggers that seem a little bit better than this thing, but this is the easiest, I think, to spin up. So list breakpoints, we don't know. So disable 4, 6. So we say break at 81. Now we continue. So now we're at 81. So we're going to print off the list. So let's disable 81. Disable 1. Now we're going to, let's break at 86. Continue. So it printed off our list here. So there's all of our scores. There's Williams and all of the rest of the students. So now we're going to print the, let's get into it. For school, let's get into it. So now we are, so for the first guy, that's Williams, I think, right? PP student. Now actually we're reading school scores. So the first one is, oh, that's the last one from the previous loop. Now we're not able, students not even being used here anymore. Now we're at school scores, right? So schools scores is this dictionary, and so we're going to print so for school and scores. So the school there is high for the first one, and the scores is that list. So we are at line 88, and so let's go to down to line for the print. Now we have a total, we have a count, we have an average, and we have a var, and then we print it off. So let's skip down to line, and we'll do the whole loop. So let's skip down to line 96, and it printed it off our data there. So now we are on number 6, and the same thing with the scores for the students, and then we can skip down to line 119. And that's basically it. That's it. So we can just look at that beautiful list of data and formatted data. But that's it. This is a long video. I hope you guys enjoyed it, and make sure that if you want to learn more about Python programming language as an introduction, we have a hangman game and a dice game and a simple reverse. That's a beginner. We just did students, but yeah, come back for the others, and we'll see you on the next video. Thanks, guys. Hello. And we're glad you're here at Coding Bootcamps. Introduction to the Python programming language. Here's what you just learned about Python 3. Using Python from the command line and a little bit about GUI constructs. We talked about language fundamentals and data and execution models and flow control constructs. We talked about conditionals, list expressions, and a bunch of expressions. Talked about exception handling and using the string object. Also talked about organizing code into functions and into classes for object-oriented. We talked about Python's list, which are called arrays in other languages. We talked about collections and dictionaries. And we worked with functional arguments. At the end, we did 4 projects. Talked about the Python, line by line, went through, looked and see what the output looked like. So congratulations. You have successfully finished this class. And probably what you should do next is learn object-oriented Python. And Coding Bootcamps has a class called Learn Python by Examples. So be sure to check that out. Sign up for that at codingbootcamps.com. And check out the social media links for Coding Bootcamps. All right, see you in the next class.